In the previous movie, you ran a simulation that calculated the time a customer would spend at each station of a sandwich shop. The code you created only allowed for a single run, which doesn't provide much helpful information. In this movie, I will show you how to add a loop to your simulation code that lets you run multiple simulations so you can get more data to analyze. My sample file is chapter 0208, and you can find it in the chapter 2 folder of the exercise files collection. The first thing I need to do is to add the number of runs for the simulation to the sim setup worksheet. Now, I could do this in code. I could put it in the VBA module, but I actually like putting it in the worksheet because it makes this particular statistic or information more visible. In other words, when you open Excel, you go directly to a worksheet as opposed to the Visual Basic Editor, and I like putting as much information as I can here so that you see it when you first encounter the workbook. So I'll enter in the data for the number of runs. I'll click cell E2, and I'll just type in number sign of runs, and then tab. And I'll change this formatting, so I'll click cell B2, and then on the Home tab, click the Format Painter and click cell E2. That copies the formatting over. And for this simple example, I'll just make the number of runs 2. So I'll type 2 in cell F2 and press Enter. Great. That's all the information I need here. So I'll go ahead and press Alt F11 to go to the Visual Basic Editor. I have opened to Module 1, and I see my code, and also in the immediate window, I see the results of the previous simulation. If for any reason you don't see Module 1, then just go to the Window menu and click Module 1 from the list. In the VBA code, there are a number of things that we need to do. The first of those variables is the run counter, which is here L run counter defined as a long, and then the number of runs, which we'll draw from the worksheet, that is L number runs, and that is here below the number of stations. So we have those in place. And with those variables in place, we can read in the number of runs. So I'll go below number of stations. Give myself a little space. I'll type a comment or define the number of runs. And again, that value is coming in from the sim setup worksheet. So worksheets, left parentheses, and then double quotes, sim setup, double quotes and parentheses close, dot activate, and then L, NMBR, runs, my variable here, equals, range, and remember it's in F2, dot value, and enter. So there is the number of runs of the simulation that we're going to do the next time I press F5. So I'll scroll down until I get to the actual simulation. Here we're defining the customer and giving it its properties. Here we are reading in the number of stations and also their properties. And here is where we start the actual simulation, stepping our customer through each station and using the mean and standard deviation time plus a random input to calculate the processing time at each station. So this is where we want to create outer loop for the number of runs. So I'll click below Next, enter twice, and I'll type in start the outer loop for customers up to LNMBR runs. So after that comment, I'll type for L run CNTR equals 1 to LNMBR runs. And just for style's sake, I'll make the F capitalized. So I have started a new loop, a for next loop for a number of runs, and we're counting using L run counter. So I'll step down, and above the place where we set the object variables to nothing, and below the previous next, which I've commented as the close of the station counter loop. I'll press enter, type in a comment, close the L run counter loop, and then type next. So again, we have defined the variables that we needed. We have read in the number of runs from the worksheet, and we have created our loop based on the number of runs. And we're counting to see how far we've gotten into the loop. One last thing I'll do is to add a little extra to the debug.print statement. So ahead of the station, I'll type a double quote, and then run, then a space, then a double quote, ampersand, L run counter, then ampersand, and I'll add a space ahead of station. So when we print out our results, we get the number of the run as well as the station. Now, if you kept your immediate window open, then you probably see the results from the previous simulations that you've run. So I'll just click in the immediate window and press Control A to select its entire contents, and then press delete. So now the immediate window is empty. I'll click back in the main body of the code and press F5, and if we did everything right, we should see two separate runs of the simulation. And there it is. If I scroll up in the immediate window, I see run 1 and the times for the 3 stations, and then scrolling down, I see for run 2 the times for those simulations as well. This was a fairly long chapter, and there was a lot going on. We did a lot of groundwork that will pay off later in the course. So even though this fairly simple simulation doesn't give us all that much information, the techniques we've practiced will give us the tools that we need to go much further in the chapters to come. One of the fundamental questions you can ask about your business is whether you have enough hands on deck. In other words, whether you have enough workers attending to a particular task. In this movie, I will show you how to change your simulation so that you can add additional capacity to individual stations. My sample file is the Chapter 0502 sample workbook. That's a macro-enabled file that you can find in the Chapter 5 folder of the exercise files collection. I do want to point out one change that I have made to the Sim Setup worksheet, and that is that I added a column to the station information area. It's called capacity, and you can see that Station 1 can handle 2 customers, Station 2 can handle 1 customer at a time, so that hasn't changed, but Station 3 can handle 2. Those 2 stations have the largest mean processing time, so perhaps a manager thought that adding an additional employee to each of those 2 stations would help with customer flow. With that background in place, I will press Alt F11 and switch to the Visual Basic Editor. I'm looking at Module 2, which has the code for the simulation, but I did make some changes, and this is a change that we haven't made before, to the station class. So I'll just go over to Class Modules and double-click C Station. So here we have the station class definition, and I have added 2 new properties to the station class. The first is called capacity, and the second is serving. And if I scroll down to the bottom of the class window, you can see the get and let statements for both capacity and serving. So everything is normal. We just added 2 new properties, and we can read and write them at will. I'll go ahead and close the station class. The reason we need those new properties is because we're allowing a particular station to handle more than 1 customer, and that means we need to know how many they can handle and also where they are in terms of customer load. So we need to count the number of customers that are in each station at a given time. So there is a fair amount of additional code that we need to add. So let's go ahead and scroll down into our code, and I have the places marked where we need to make changes. Okay, so here's a comment, and we're within the loop where we're trying to figure out how to handle each customer, so that makes sense. The change we need to make here is, instead of looking to see whether a station is idle, we need to check if the station is at capacity or not. So to do that, I will change this line to the following. If stations, and we're still looking at the same station, so that's object C dot next station. So if the next station, if it's serving property, and again, that's the number of customers it's currently serving, equals stations objc.nextStation.capacity, then. So what we've just done is, once again, instead of measuring whether the station is idle or not, whether it's serving the number of customers equal to its capacity. Now we need to make our second change, and we'll do it here, below the comment that says to make the second change here. This code takes a look to see if the current station is idle or not. If it's not, then it takes some action. So what we need to do is change this line from whether the station is idle or not to whether we can add another customer to it. So we have stations, and again, object C.station. That's its station ID number, dot serving, equals itself +1. So what we just did was to change the statement that changed the idle status of a station from 1 to 0 when it was occupied with a customer, to adding 1 to the serving property. So now, instead of a station perhaps serving 1 customer, it is now serving 2. There are 2 other changes we need to make, so I'll scroll down and look for make third change here. There it is. This line of code sets the station's idle status to 1, indicating that it is in fact idle and can accept a customer. What we need to do here is to reduce the number of customers that a station is serving by 1. So in other words, the customer has just left, so we need to reduce the number being served by 1. So I'll actually keep stations object C station, and I'll delete everything to the right of the period. We'll use the serving property equals, and again, it is equal to itself. So I'll just copy and paste, select Control-C, Control-V, -1. There's one more change we need to make, and it's right here, making where my note says make the fourth change here. And in that case, it's basically a special case that we needed to implement in the if-then-else statement to set the station's status to idle again. And we can use the exact same code that we used before. So we just entered code where we set the serving status to itself -1, and we'll do the same thing here. So I'll just copied by selecting and pressing Control-C, select the code we need to change, press Control-V, and we're done. Those are the only changes that we need to make. And again, the idea behind all of these changes was that because we add the capacity to each station, we need to either add or subtract 1 when a customer enters or leaves the station. In the approach to process modeling demonstrated in this course, I am using classes to represent business objects, such as customers and stations. When you create an instance of a class, you can add that instance to a collection of objects, and in this movie, I will use a for loop to move through the objects in the stations collection to calculate processing times. I'll use other techniques later in this course, but I wanted you to see how for next works in this situation. My sample file is the Chapter 0205 workbook, and you can find that in the Chapter 2 folder of the exercise files collection. The code that we created earlier reads in information from the sim setup worksheet, and that is the number of stations and also the mean or average processing time and standard deviation for stations 1 through 3. Now we can add some VBA code to use the information that's included in this worksheet to calculate processing times for the stations within a simulation. So I'll press Alt F11. Over in the Visual Basic Editor, I am currently looking at the Module 1 code module, which contains the main test subroutine that we've been using. If you didn't open to this particular module, then you can either go to Window, and in that menu click Module 1, or you can go over to view the modules within the Project Explorer and double-click Module 1. But we're here now, and what I want to do is to generate random processing times for each of the 3 stations that are used in this simulation. So I will scroll down through the code that we created earlier in this chapter until I find at the very bottom step through stations using a for next loop. So the first thing I need to do is to initiate the loop. So I'll type for, and then my counter variable will be the stations counter I've used before, L stcntr equals 1 to L nmbr stas, and I'll press enter 3 or 4 times and then type next, so I don't forget to close out the for next loop when I'm done. And then I'll press tab to indicate the code that I'm creating now is within the for next loop. And the first thing I'll do is move my customer, which is customers 1, I only have 1 customer in my collection, to the station, station, represented by the current value of the station counter. So that's L stcntr. That C needs to be capitalized. So what I've done is to create, again, a for next loop that goes from 1 to the number of stations, which, pressing Alt F11, we see in cell C2 is 3. Switching back. And because the station counter is equal to 1, I can set the customer's station property to that value. So the customer, as far as the simulation is concerned, is currently in station number 1. Now, station times aren't deterministic. In other words, you don't know for a fact that when you go to station 1, it'll take 15 minutes or 15 increments of time, however you choose to measure it. Instead, it's random, and the way that we use randomness is to generate a random processing time. So I'll just add a comment, generate random processing time. And I need to assign the random value, which I will generate to a variable. So I declared a single precision floating point variable called sngrand, and I'll use the rnd keyword. rnd followed by a pair of empty parentheses. rnd is the Excel VBA equivalent of the rand function in the worksheet. Ever since 2007, the rnd function in VBA and the rand function in the worksheet use 2 different algorithms for generating the random values, but for our purposes, they're both good enough. Now I need to assign a value for the amount of time that each customer will spend in a station. And I'll do that by combining the random decimal value created earlier with the mean and the standard deviation of processing times for the station. So I will assign that calculation to LSTA time, which is a variable declared earlier, equal. And now I will use the norm inverse function from the worksheet. In other words, it's a worksheet function. It's not something I have to create in Excel VBA. So I'll type application.worksheet function then a dot, and then norm underscore INV. And what this does is it takes the inverse of the normal distribution. So what you do is you give it a random input, the mean and the standard deviation of this particular distribution, and it will calculate the relevant value for you. You need to give it 3 arguments, so I'll type a left parentheses, and the first is a random value, or a value, and in this case I'll make it SNG rand, comma, then the current station's mean processing time, so that is stations, and then the index, or the number, is L, STCNTR. In other words, the number of the counter that we're currently at in the for next loop, period, station mean, so STAMEAN, then a comma. Now I want to move my code onto a second line, so I'll type an underscore followed by a space and enter, and then I'll space over twice to indicate that this code is a continuation. And I now need to include the standard deviation, so similar to what we did before, stations, L, STCNTR, dot station, STASD, followed by a right parentheses. So that closes out that statement. And I'll press enter twice and backspace to realign the code that I'm entering. Now we need to write the processing time, and rather than write it to the worksheet, we'll just use debug.print to send it to the immediate window. So just do write processing time, then press enter, and note that the single quotation mark made that last statement a comment, so it won't be executed. Now I'll type in debug.print, and I'll type the string that I'm using, station, then a space, followed by double quotes, ampersand, then the value stations, left parentheses L, STCNTR, list counter, in other words, or a station counter, and then the station ID property, STAID, then another ampersand, which allows me to string various elements together, and a space, time, make the T lowercase, then a colon, and a space, a final double quote, then an ampersand, and LSTA time. So what this fairly long statement does is to use debug.print to write station, followed by a space, then the station number, which is the station ID property, followed by a space, and then time and a colon, and a space, which is followed by the time that was just calculated using the mean, standard deviation, and random input. Now I'll scroll down, and I'll just add a note to myself that we are closing the L station counter loop. And we have all of our code in place. When we're ready, we can run the simulation. Adding a ticker to a simulation lets you track the state of each customer and station precisely as the simulation moves along. We almost have a working version of a simulation that includes a ticker, but we still need to add a line of code that writes out the state of the simulation at each step. So in the previous 2 movies, we added many different lines of code and had a lot of explanation. In this movie, it's just going to be a couple of lines. I thought you could use a break. So as before, I will use debug.print to write those results to the immediate window. My sample file is chapter 0304. It's a sample file you can find in the chapter 3 folder of the exercise files collection. We won't be working directly with the sim setup worksheet, so I'll just press Alt F11 to move to the Visual Basic Editor. And here is the code module that we're using. And I'll just scroll down. You've already gotten explanations for what all of the code above here does, adding customers and stations. So I'll move down to where I want to write my results. And that's here within the ticker or timing loop. And I'm going to write it after a customer is done with a particular station. So I will click to the right of the line just below the else colon statement, where we set the station for the current customer to its next station. So in other words, it is now done. So I'll press enter, and I'll do that again actually, and I'll type in a comment: output results using debug.print, then enter. And now I'll type in the debug.print statement. I'll type it in and then explain exactly what it does. So I have debug.print, then a space, and then double quote, I'm a customer, then a space, then a double quote. And now we need to identify the customer, objc.custid, space, should be an ampersand. Then after double quotes, a space, and I'm in station, space, double quotes, and objc.station, then and then I'll do a space and underscore and then a space again so we can wrap. So I'm in station, obj station, c station, and then a double quote, a space, at time, then a space, double quotes, ampersand, and L ticker. Okay, so what I've done is I've used the ampersand, which is the concatenation operator, to string several different variable values and literal text strings together. So what'll happen is that the debug.print statement will write down here to the immediate window, text to the effect of I'm customer, let's say it's customer number 1, the customer ID number, and I'm in station, whatever that customer's current station is, let's say it's customer number 2, at time, and then it will give the ticker value. In other words, where are we within the simulation? And again, those values will appear here in the immediate window. And that is all we need to run our simulation, which we will do in the next movie. Now that we have the structure in place to calculate each customer's arrival time, with the first time starting at 1, we can add the code to create new customers when the ticker, the simulation's internal clock, reaches that arrival time. In this movie, I will add the customer generation code we need so that we can add the customer, and we'll also calculate the arrival time for the next customer as well. My sample file is chapter 0403. It's an Excel macro-enabled workbook that you can find in the chapter 4 folder of your exercise files collection. The sim setup worksheet contains the Poisson data and also station data that we'll be using in the simulation. So I'll move over to the Visual Basic Editor by pressing Alt F11. And here we have our code for the Update on Tick Simulator module. I'll go ahead and scroll down to the place where we need to add our customer creation code. But to save you some busy work, because I know we had a couple of long movies in the last chapter and this one, I'll just show you what I've already added. The first is to set the total ticks for each run. And a tick can be an arbitrary unit, so it can represent any amount of time that you want. In this case, to keep the number manageable, I have my total ticks equal to 2880. Indicate in my comment, each tick represents 10 seconds in an 8-hour day. So you have 2880 of those ticks. I also initialize the lCreateNextAt variable, which tells the code when to create the next customer, to 1. And I also initialize the customer ID counter variable to 1 as well. So we'll create customer 1, then increment that value to go to customer 2, and so on. So we're creating our loop. And instead of going from 1 to 85, as we did in chapter 3, we'll go from 1 to L total ticks, which again is 2880. So here I have my comment. Check if a customer is due to be created on this tick. If not, do nothing. But we do want them to be created, so I'll go ahead and type in the logic that we need for that. So I'll press Tab to move in, and if L ticker equals L create next at, then we'll do the following things. We'll set object C equal to a new object variable of type CCustomer. And again, that is the customer class that we created earlier in the course. So we have our customer variable, or our object C variable, and now we can add it to the customers collection. So we have customers.add, a space, and then objc, which is the customer object variable, and enter. Now we can start assigning customer property values. So we have customers, and the customer number is lcust ID counter .custid space, then equal, and lcust cust ID cntr, and then enter. Now I'll save myself a little bit of typing time by copying the customer's lcustomer ID counter and a period. So I'll select that and press Control C, and then Control V to paste, and we'll make the start time equal to 1, enter, then paste again. Next station, next sta equals 1. I can paste again. Is idle equals 1. So when it first enters the system, it's waiting on station 1 and it's not doing anything. Then we have the idle time property equals 0 because it hasn't done anything yet. And then finally, we need to indicate when the customer entered the system. So Control V and then entered equals, and this is the ticker value. So LTICKER. Then enter twice. Now we need to recalculate the active sheet, which is, as we do here, sim setup. So we need to recalculate that sheet to generate a new arrival time. So we have active sheet.calculate, calculate, enter, and then L create next at equals L create next at plus active sheet dot range, and our value is in cell K2. So this bit of code just pulls whatever value is currently in cell K2, which was the randomly generated Poisson number, dot value. Last thing we need to do within the if statement is to increment the customer ID counter. So lcust ID counter equals itself plus 1. And with all that done, we can type end if to close the if statement. So once again, we have added the code that we needed to create a customer whenever the variables tell us to. As soon as we create one, we tell the simulation when it should create the next one. In the previous movie, you added the framework of if-then and for-next statements used to manage the movement of customers through a series of stations in a business process. It was a lot of work, and frankly, I wouldn't be at all surprised if you stopped typing along with me partway through and just watched to get a general flavor of what was going on and moved ahead to this video. And frankly, I don't blame you. I did it so that you would be able to see where all the code went, but I wouldn't be at all surprised or blame you if you didn't type it all in yourself. If you did, good on you. If not, no problem, because you'll see it here. And in this movie, we will fill in the detailed instructions for all of those statements, so the process will move customers to the next available station at the appropriate tick of the clock. My sample file is chapter 0303. That is an Excel workbook you can find in the chapter 3 folder of the exercise files collection. We won't be working directly with the sim setup worksheet, so I'll just press Alt F11 to go to the Visual Basic Editor. And here we have all the code that we added earlier, so I'll just scroll down to the point where we need to add the first bit. So we're adding our customers, we're setting up our stations, and here is the meat of the code. The first bit of code is below the line, the if-then statement that checks to see if a customer's next station is idle. If it isn't, in other words, if it is busy and this particular property is set to 0, then we need to add 1 to the customer idle time. So I'll go below my comment and I'll type in the code that does that. And that is objc dot idle time equals objc dot idle time, the same variable, plus 1. So we are incrementing that value by 1. Now we can go down to the else statement below it, and this is where we do several things. We move the customer to the next station, then set the station's idle property to 0, calculate the customer's processing time, set the customer idle time to 0, and then set the start time property to the current ticker value. So those are a number of statements that we need to include here. So I'll go ahead and start working. The first step is to move the customer to the next station. So objc.station equals objc.next station. I'll press enter twice. Now we need to set the station's is idle property to 0. So that is stations. And that is the number of station referred to by the customer's current station. So that's objc.station. And then we use the station is idle property, staisIdle, equals 0. So we have just indicated in code that the station is now busy. And we can also update the customer's next station based on the next station property of the station he's currently in. So in other words, if he is in station 1, we need to set his next station to station 2. So it's kind of convoluted because I use similar terms, but I did use differing variable names, so hopefully it'll stand out a bit better. And the code for that is objc.next station equals stations. And again, objc.station.next station, next STA. So we have assigned that property correctly. Now we need to calculate the processing time for the customer while they're in the station they're in at the moment. So we've done all of the updating that we need to do for what happens after we're done processing in the station. But now we need to calculate a random processing time based on the standard deviation and mean that we drew in earlier from the worksheet. So first thing we need to do is to generate a random number that is a decimal between 0 and 1. And we have single rand as that variable equals, and then we'll use the keyword RND. And then open and close parentheses and return. Now we need to add our processing time to the current ticker value. So the end time, objc.end time, equals L ticker plus, and then here's where the fairly long random number generation statement comes in. We'll use the norm inverse function to generate a random value based on a particular distribution. So that's application dot worksheet function dot norm underscore inv, and then we need to pass in 3 values. The first one is the random value, random number that we generated, single rand, then a comma. Then I'll do a space and an underscore, again followed by a space, so that we can continue on to the next line. Hit space twice to move in, make it easier to read. Now we need to find the mean processing time for the current station. That is stations, objc dot station, right parentheses, dot sta mean. So that is the station's mean processing time. Now we do the same thing for the standard deviation. So I'll type a comma, and rather than retype, I'll just copy the station's objc.station text. So where I currently have STA mean, I actually want STA SD, which is the station standard deviation. And I'll type a right parentheses to close that out and press enter. Let's see if I got it right. Yes, I did. Got it on the first try. And now we need to indicate that the customer is no longer idle. We set its isIdle property to 0. So I'll space in twice, objc.isIdle equals 0. And then we can also assign the start time property, the value that is currently on the timer or the ticker. So we'll make that objc.startTime equals L ticker. And I'll scroll down so you can see that we have reached, or we're just on top of the end if statement. So I have closed out that particular section of code. Now we'll go down to the other element that we need to add, and that is what do we do if the customer's end time for the station it's in does equal the ticker. In other words, what do we do when a customer is done at a particular station? Well, there are 3 things we need to do. We need to set the station's status to idle. We need to set the customer's status to idle, and we need to update the customer's station to its next station value. In other words, we need to say the customer's done, the station's done, and the customer is moving on to whatever the next station is. So go down below where I have the comment, and I'll type in 3 lines of code. So first, I need to set the customer's current station to idle. So stations, left parentheses, objc for the current customer, period, and then its property is station, right parentheses, period, and then the station property I want is station is idle. So that's STA is idle equals 1. So we're indicating that the station the customer is currently in is now idle because the customer is done. Press return, and then the customer is also idle, so that's objc dot is idle. Oh, excuse me, picked the wrong one. Is idle equals 1. Enter, and then we need to move the customer to the next station. So that is objc dot station equals objc dot next station. Right, so there we have it. That is a lot of code. But what we've done is to flesh out the interior of the loops that we'll be using to check each customer status and do what needs to be done based on whether it's idle, whether the station it wants to move to is idle, and what its processing times will be. So far in this course, we have based our discussions and simulation code on a business process that has 3 stations. In the last 2 movies, we added and tested adding capacity to those stations, and I've left those changes in the code. But what I'd like to do now is show you what happens when you add additional stations to the simulation. My sample file is chapter 0504, and you can find it in the chapter 5 folder of your exercise files collection. The Sim Setup worksheet currently has information for 3 stations. So I'm going to add 2 more. The first I will call station 4. So I'll click cell B8, type the number 4. Now I need to enter its mean processing time, that's 12. Standard deviation of 2. The next station, which is 5, and its capacity, which is 1. Now I'll press enter and go back to cell B9. This is station number 5. Its mean processing time is 14. Press tab. And then in D9, I'll enter its standard deviation. That's 4. The next station is -1. When a customer is done, has gone all the way through the process, then we set their station to -1. And that station's capacity is 2. And enter. Now there's something very important to remember. And I would imagine that a lot of you have already seen the possibility for error here. The way that the code in these modules is implemented is that the VBA code reaches out to cell C2 to discover the number of stations that are in the simulation. You could add VBA code to count the number of rows, starting with B5 and so on, but I prefer to actually make the information more explicit within this worksheet. It introduces a possibility for error that if you have a different number of stations as the number of station objects that you're attempting to read in, then you can get errors. Specifically, if you go to station number 3 and the code attempts to move a customer to station number 4, then you get a subscript out of range error. So I got a couple of those until I realized what was going on. I have 5 stations in the simulation, so I will edit the value in C2 to 5. And that's the only change we need to make. The code in the simulation actually reads the number of stations and then comes to cell B4 and uses that as the base to read information about the number of stations that are indicated in cell C2. So to add additional stations, all you need to do is type in the station number and the other information. No business process is perfect, and even though the ideal is to have a customer visit each station within a business exactly once, there are many times when a customer either needs to revisit the station or needs to spend more time due to a communication error or some other possibility. In this movie, I will show you how to implement changes that let you add time that a customer spends at a station. My sample file is chapter 0506, and you can find it in the chapter 5 folder of your exercise files collection. In operations research, anytime a customer needs to spend more time at a station or needs to revisit a station, you have what is called a rework loop. That means that you need to rework whatever was done at that station. There are a number of ways to implement rework loops, but what I've decided to do for this course is to provide a possibility that a customer will have to spend more time at the station they are currently in. If you want, you can extend the simulation code to have them go back to another station and then revisit the process, but that's significantly more complicated than I want to do here. Before I switch over to the VBA code, I would like to show you the change that I've made to the results worksheet. So I'll go ahead and click that. In addition to information about the time that each customer spends within the system, I have added an area where the code can write out the customer ID, the station, and the rework time. So in other words, we want to know which customers at which stations spent how much time during a rework loop. So with those changes to the results worksheet in place, I'll go ahead and press Alt F11 and switch to the Visual Basic Editor. In the Visual Basic Editor, I see the Module 2 code module, and I'm in a subroutine called Rework Loops. What I want to do is to add code that indicates whether a rework loop has happened, and if it does, how much time has been added. So I'll scroll down, and what we'll be doing is adding the code to the part of the internal loop that calculates how much time a customer spends within a particular station or at a particular station. So after we calculate the amount of time a customer spends at a station, we need to check for a rework loop, and if there is one, how long it is. So I'll click below, check for a rework loop, implemented as a longer stay in the station, and add the code that we need. We're going to be using our code up here to generate basically a second iteration through a station. So we need to use the single random variable again. So SNG RAND equals RND with 2 open and close parentheses, then return. Now we can do our if-then statement. So if SNG rand is less than or equal to 0.05 then, and I'll press return a couple of times and type end if, so that's the end of that statement. One thing I should point out is that it is very easy to make mistakes with decimals. The way that I like to write decimals is to have a 0 to the left of the decimal point. So I was careful to write 0.05. I just think it's easier to put the 0 there and use the period as a clear marker. You might prefer just to do the period. It doesn't really matter. But one problem that I have, and I think that other folks who use a 0 to the left of the decimal point might also have, is that when you're writing 5%, which is 0.05, it's very easy to write 0.5. So you'd have a rework loop happening half the time. I made that mistake the first time I implemented this code, and I was shocked at how many rework loops there were. I had a pretty good idea what I'd done, but even so, it's something you should look out for. So remember, it's 0, point, and then your percentage. All right. With that out of the way, I'll press Tab to move in, and I'll start adding my code. So I have L rework time, and this is a variable that I defined earlier, or declared earlier, then equal, and I'm going to use the exact same code that I used here to generate the rework time. So it's application, worksheet function. Because I clicked away and I'm copying code, I got that error message, so I just clicked OK, but that's fine. All I want to do is copy this code here. So I selected the application.worksheet function code and went all the way down to STASD, which is the station standard deviation. And I'll click where I was typing before and press Control V. And I'll space a little bit to make the code a little bit more attractive. Okay. So what I've just done is to calculate rework time using the exact same parameters as the initial loop. So it might not be the same time. In fact, going on form, it probably won't be, but it does add an additional turn through a station for a customer. Now I need to calculate the new end time for the customer based on the rework loop. So I'll go there, and we have objc.endtime equals itself, and I'll just type it, objc.endtime plus L rework time. I'm just checking to make sure I typed everything right. Okay, it's good. Now, one more thing that we need to do is we need to make sure that the customer spends at least one tick in a station. One problem that I had earlier on in the simulation is that when you have times or mean times such as 10 and a standard deviation of 3, it is entirely possible to get negative values. So we need to make sure that the rework loop is at least one tick long. So I'll go above the code, and I'll just scroll down so it's on the screen. So I'll need to make sure that rework time is at least 1. So I'll say if L rework time less than or equal to 1, then L rework time equals 1. Or actually, if it's less than 1, then it's 1. Okay, so that will prevent any of the timing errors that I had earlier, where occasionally a customer would get stuck because their end time at a particular station was from the past, in other words, a time that had already passed, so they were never going to leave. Now I need to add code to write out the rework time results to the results worksheet. So I'll scroll down, click here, and I can just write in my results. I'll put in a comment first, write out the rework time result, enter. And now I need to activate the results worksheet just to make sure. And the name of the worksheet is in double quotes and parentheses, .activate, and return. I want to activate cell J1, so active sheet, .range, and in double quotes and parentheses, I have J1, .activate, and we're writing out 3 separate values. the customer ID, the station, and the rework time. So I'll have active cell dot offset, and this will be a reference that tells Excel how far to go from cell J1 to write its value. Left parentheses, and that is L rework counter. And this is a variable that I declared earlier in the module, in the code module. I wanted to save you some busy work, so I just wanted to mention it as I got further down. Comma, 0. So it's 0 columns to the right from the active cell of J1, but 1 row down. Right parenthesis, and we'll set its value equal to object C, which again is our customer, dot customer ID, and return. Now I'll just go ahead and copy this code and paste it in below, so I have a little less typing to do. I'll change the column offset to 1, and I'll change the customer ID property to station. So we're writing out the station where the rework loop occurred, and enter. And I'll paste back in the active cell offset, should be a 2. So we're going the rework counter rows below and 2 columns to the right of cell J1. And the variable that we want to write isn't one of the object's properties. Instead, it is rework time. So L rework time. And finally, we need to increment the L rework counter variable. So L rework counter equals L rework counter plus 1. And I'll just scroll down to make sure I added the end if. I did. And we have ended our rework check. So to recap, what we have done here is to determine, using a random value, whether a rework loop is required for a customer at a particular station. We set our probability at 5% or 0.05. If that is the case, then we calculated the rework time, making sure that it was at least 1, and then we incremented or added the rework time to the end time for the customer at that station. And then to record the amount of rework time that was entered, we activated cell J1 of the results worksheet and wrote out the customer ID, the station, and the rework time. When you model the amount of time between events, such as customers entering a store or cars arriving at a toll booth, you use the Poisson distribution from statistics to calculate those inter-arrival times. There's no easy way to calculate Poisson distribution results using a single Excel function, but in this movie, I will show you a straightforward way to get the values you need by using a series of worksheet formulas. My sample file is chapter 0402, and you can find it in the chapter 4 folder of the exercise files collection. So let's take a look over on the right side of the worksheet, specifically starting here under the Poisson data label. The Poisson distribution uses a single input value, which is the mean, to calculate its curve. If you read about the Poisson distribution in mathematical literature, you will see the mean referred to as lambda. In this case, I have set the mean at 20, and I've also, in cells L2 through L55, set up a series of values that the Poisson distribution with a mean of 20 is likely to take on. Now I need to create the formulas for the distribution results in cells M2, which is here to the right of 0, all the way down to M55. So to do that, I will select cells M2 through M55 by going to the name box and typing M2 colon M55 and enter. Those cells are now selected. And now the active cell is still M2. So I will type in the following formula: equals Poisson.dist L2. I'm typing that value as a relative reference so that it will change, then a comma. Now I need to type in the mean, and that is in cell J2. But I want that to be an absolute or unchanging reference, so I'll press F4, then a comma, and now I need to indicate whether I want the cumulative distribution function or the probability mass function. In this case, I want the cumulative distribution function. So I'll type true, right parentheses, and now to enter my formula into every selected cell, I will press Control Enter. And there you can see I have my values. So any value that is less than 0. And then 8 zeros 2 will be 0, then 1, and so on. So there is an outside possibility that this function could generate a 0, but it is extremely unlikely. The most common value would be somewhere between 17 and 21 or 22. Those are the most common values that you'll see. Now I need to create a cell formula that will do two things. The first is to generate a random value between 0 and 1, a decimal value, and then have Excel look up which value within column M it is less than, and then return the value from column L based on the random value that was generated. So I'll click in cell K2, I'll type equal, and I'll type the following formula. So that is match, left parentheses, rand, and open and close parentheses. That, again, is the seed value, or the random value that we're using to look up. And we have M2 to M55. I'm not copying this formula anywhere, so I don't need to worry about making the references relative or absolute, comma, and then 1. So we're looking for a value less than. And then I'll type a right parentheses to close it out and press enter. And I get my value, which just happens to be 20 this time. And now every time the worksheet is recalculated, we will get a new value in cell K2. So for example, if I click cell K2 again, go to the Formulas tab and click Calculate Now, I get a new value of 17, and clicking it again, it goes up to 26, and so on. You might see different random values when you recalculate that result. You can also recalculate a worksheet by pressing F9, but that is a hotkey in my screen recording program, so I can't use it here. So either Calculate Now or F9 to recalculate the entire worksheet. If you want to change the mean, for example, from 20 to, say, 13, then you can do so. But if you look over to the right, you will see that the values in the lookup columns have changed. So, for example, you might see 1, which indicates the terminal value, or at least the terminal likely value as Excel calculated it, as moving to, say, 45, 46, or something like that. That's not a problem if the mean is lower than the table you created. However, if you create a mean that is greater, say, for example, going up to 25 or 30, then you won't have enough values on the right side in your lookup table to generate what you need. In that case, use the fill handle to copy the Poisson.dist formulas that you created in column M and drag it down until you see a result for 1. And then extend the series for the lookup values on the left, the ones that currently end at 54, and drag it down so that you have 55, 56, 57, however many, until you cover the entire column of Poisson distribution values. Now that we have a means of calculating Poisson arrival times, we can add that information to our simulation. One of the most overlooked tools in Excel is the Excel table. Excel tables are based on lists, which is a set of data where each column contains a specific value. That could be a customer's identification number or the time the customer entered the system, and each row represents a full set of values for a customer. In this movie, I'll show you how to create an Excel table from your simulation's output. My sample file is chapter 0603, and you can find it in the Chapter 6 folder of the exercise files collection. The results of our simulation have been written to the results worksheet, so I'll click its tab to display it. And here we see the data as it was written out. And notice that row 1 from columns A to H, contains the headers that will be used when we create the table. To create the table, we select any cell in the list, and then on the Home tab of the ribbon, in the Styles group, click Format as Table, and then click the table style you want to apply. In this case, I will click Table Style Light 13. Then in the Format as Table dialog box, I'll verify that Excel has identified my data. A1 through H145 looks right, and also the My Table Has Headers checkbox is checked. So everything looks good there. I'll go ahead and click OK. And when I do, Excel creates the table. Now note that because of the filter errors that were added, some of the text in the header row is obscured. So what I'll do is I will select columns A through H. And what I did was I just clicked and dragged in the column header row here. So I just clicked on the column A header and then drag the mouse over to the H column while holding down the left mouse button. And now I can hover the mouse pointer over the right-hand border of one of the columns, and when the mouse pointer changes to the two-way horizontal arrow with the vertical I-bar, I can double-click, and Excel automatically resizes each of the columns so that all of the text in the headers is displayed within the column cells. Creating tables is an easy way to add a lot of additional functionality to your results worksheet. When you create a simulation, you model the behavior of business objects, such as customers, as they move through an environment. That environment is made up of other business objects, such as customer service stations within a store or some other locale. In this movie, I will show you how to define classes, which are structures within Excel VBA that represent types of objects, such as customers or stations. My sample file is the Chapter 0101 workbook. That is an Excel macro-enabled workbook you can find in the Chapter 1 folder of the exercise files collection. And no, your eyes do not deceive you. This worksheet is currently blank. We're going to be doing all of our work for the next few movies in Excel VBA. So to open the Visual Basic Editor, I will press Alt F11. Doing so opens the Visual Basic Editor, and you can see over on the side the VBA project window. If for any reason you don't see the project window, you can just go to View and click Project Explorer, or you can press Ctrl-R. Another thing to look for is whether you have other workbooks or any add-ins that use VBA. If you do, you will see them over here, also in the project window or Project Explorer. You want to make sure that you are adding the modules, both class modules and code modules, to the workbook that contains the code and worksheets that you want to use. So in this case, we are in the correct place, VBA project. And another thing to watch out for, make sure that you do not have any individual worksheets selected. You want to create a class module and your other code outside of a particular sheet. To insert a class module, go to the Insert menu, and then in the menu, click the Class Module item. Doing so creates a new class module, and you'll see over here in the Properties pane that it has the name Class 1. Class 1 isn't particularly descriptive, so we'll need to change that. Our class will describe customers, so I'll click in the name field, delete Class 1, and then I'll type the name of my class, but I'll put a C in front of it. So in this case, I'll have capital C, then another capital C, and the rest of the word customer. So capital C, and then the rest of the word customer, and press Enter. The reason that you put a C in front of customer or any other class name is mostly tradition, but it's a visual reminder that you are in fact working with a class instead of some other variable type. And that is how you add a class module to Excel VBA. Once you have that module in place, you can add variables and properties and other class elements that you can use in your program. After you define a class and its properties, you can create an object that is a member of that class. In object-oriented programming, an example of a class is called an instance. For example, if you are simulating the movement of customers through a sandwich shop, you would create instances of the shop stations as well as an instance for each customer that visits the shop. After you create the instance, you can assign values to its properties, and that's what I'll show you how to do in this movie. My sample file is chapter 0103, and you can find it in the chapter 1 folder of your exercise files collection. The worksheet is blank. We're doing all of our work in Excel VBA, so I will press Alt F11 to go to the Visual Basic Editor. I have left the customer class declaration module open so that you can see what we've done. This class module has variables for each of the 6 properties, and I have both get and let methods so that outside users and myself as a programmer can both read the values and write values to those properties. But what I want to do now is to actually declare an instance of a customer and to use it. To do that, I need to put in a regular code module as opposed to a class module. So again, I'll make sure that I'm working in the proper workbook, and I'll click Insert and Module. And here I have a code module. I'll start by typing in a name of the procedure. So I'll just call it sub sim test, and then a pair of open and close parentheses, and press enter a couple of times to give myself some blank lines to work with. Now I can declare an object variable as a type of customer. In other words, I can use the class that I just created, just defined, and set an object variable as a member of that class. So I'll type dim to dimension the variable, and then I'll name the variable objc, which to me says an object of type customer, then as, and then the name of the class, which is C customer. And you can see that Excel VBA, and specifically the Visual Basic Editor, understands that the class is available for use, and it appears in the autocomplete list. So with C customer highlighted, I'll press Tab, and then press Enter twice. Now I can use the set keyword to create a new instance of a customer using the variable object C. So I'll type set space and then objc, then a space, then equal. And you define object variables using new. So I'll create an instance by typing new. And then I can choose the type of object that I want to create. In this case, it is C customer. So I'll use the down arrow key to highlight it in the autocomplete list, press Tab, and then press Enter twice. Now I can set property values for this particular object C variable, which is of type customer. So just as you can rename a worksheet by typing activeworksheet.name equal, you can do the same thing, assigning a value to a property using object C or objc as your base. So the object is again objc, then a dot, and after I type the period, I see a list of properties that I can use. And again, these are all the properties that are defined in the class module. So I'll highlight customer ID, CUSTID, and press Tab, and a space, and an equal sign, and I'll set it as 1. And I'll just do one more. So objc, period, and I'll move down to start time to highlight that, press Tab, equal, and I'll also set that as 1. After pressing Enter twice, I should now test to see whether my assignments actually worked. And I can use that by using the debug.print statement. Debug.print sends the output to the immediate window, which is not currently displayed, So I'll go to the View menu on the menu bar and click Immediate Window. I could have also pressed Control G. So there the immediate window appears at the bottom of the screen. I'll click back up in the code module and I'll type in a command to print. So I'll use debug.print space and then the name of the variable, which is objc dot, and I'll do customer ID. So there I have my code. I created the variable of type customer. I made it an object, and then I assigned 2 property values, and if I did everything right, I will be able to print out the value of the customer ID to the immediate window at the bottom of the Visual Basic Editor. So I'll go ahead and, with the cursor flashing within my subroutine, press F5, and I see down in the immediate window that in fact I did get the customer ID of 1. That is how you create an instance of a class and assign values to its properties. In this chapter, you will add a timer or ticker to your simulation and update each object's status with each tick of the clock. For example, suppose a customer will stay at station 1 until tick 20. With each tick, you must update the clock and check the customer's status against that value. If the time is less than 20 ticks, the customer stays at the station. On the 20th tick, however, the customer must be moved to the next station and the statuses of the customer and station updated appropriately. In this movie, we will start out by adding the for next and if code that we need to manage the process. Now, this is a lot of code, so we're going to break it up into a couple of different movies. In this movie, I'm going to start by just creating the skeleton of the different statements and structures we'll use. And then in subsequent movies, I will add the specific code that operates within each segment. My sample file is chapter 0302. That's an Excel macro-enabled workbook you can find in the chapter 3 folder of the exercise files collection. We won't be doing any work in the body of the worksheet itself, so I'll press Alt F11 to go to the Visual Basic Editor. I'm in the VBA project for chapter 0302, as I can see over here in the Project Explorer, and the module named Ticker Routine is available and open for editing. I still have my class modules, customer and station. I won't go into them because they haven't really changed. Now, taking a look at the main code here in the subroutine that tests out the ticker method, I have my variable declarations, which we covered earlier in the course. And then as we scroll down, see that we're creating 2 customers, customer 1 and customer 2, using this for next loop. And we're assigning a customer ID, start time, the next station, and whether they're idle or not. And then scrolling down a bit, you can see that we're creating station objects and initializing values. We're starting at cell C4 on the Sim Setup worksheet and reading in values from the table that I had there. And again, this is all code that we've worked with earlier in the course, so I won't go into detail now. If we scroll down, I can see a comment that I added telling me to create the ticker and internal construct starting here. So I'll click below that comment and start work. The first thing I need to do is to create the ticker, which is the timer that runs behind the simulation, and that will be a for next loop. So I'll type for, then lowercase l, ticker, T-I-C-K-E-R, with a capital T, equals 1 to 85. I ran the simulation quite a few times on my own, and I found that 85 ticks on the clock is sufficient to demonstrate the concepts we're going for. So I've got 85, and then I'll hit return or enter a number of times, and I'll type in next. And then a single quote so that the rest of the line is a comment, and I'll name the variable that I'm using in the for next loop. So in other words, I know which loop I'm closing there. So I'll go back up, and I'll tab in to set up a second level. Now, we're going to be working with objects in the customers collection, The object variable we have for customers is called objc, and then the collection is called customers. And again, these are all things that we've set up earlier, so I won't go into more detail here. Instead, I'll just type for each objc. The letters obj, which stand for object, are lowercase. The C is capitalized to set it apart. In customers. So I've got that, and I'll use the down arrow key to move down. And now I want to close out this for each loop using a next statement. So I'll type next, and then another single quote to indicate the rest of the line as a comment, and objc. And go up after I hit return. Okay, so we've got the outermost parts of the loop ready to go. Now we need to start looking at the status of each station. The first thing we need to do is to see whether the customer is done. And the way that I indicated that status, and again, this is from chapter 2, is by setting the station to -1. So that means if a customer's station is -1, then they are done, they've left, they're eating in the dining area, whatever. But in this case, we need to check to see if the customer is done. So I'll press tab twice to move in, because I'm moving inside of my 4 next loops. And I'll type if objc period. And then we're checking the current station. So it'd be station, and then not equal to -1. So what I'm doing is I am checking to see if the customer station is not -1. If it is, however, equal to -1, then we'll just skip past this part of the loop, and that customer will be ignored. Now, the processing downside to doing it this way is that we have to check every customer in every turn. However, for simplicity of coding, that's the decision I made. So if you're an experienced coder, I'm certain you know how to get around it and manage that issue by itself. However, I don't have those skills in my toolbox yet, so I'm doing it this way. All right, so this is the if statement for customers in stations. Oh, I forgot my then. So after the -1, I'll type then, and I'll press enter a number of times, again, to give me some more white space. And then I'll type end space if, and a single quote, and I'll make that comment station not equal to -1. So that reminds me of what I was checking for. All right, I'll go back up. And you guessed it, we do need to check another property of the customers. The next thing we need to do is tell if a customer is idle. In other words, if the customer is idle, that variable is set to 1 for true, and it means that the customer is waiting to go to the next station. We've already determined that they haven't exited the system, so now we need to know if they're actively engaged in a particular station or if they're waiting to move to one. So this next element is to type if objc dot is idle. If that property is equal to 1, then we need to take action. We need to do certain things to that object. And in this case, we need to actually take several things into account. So I'm going to go down a bit. And I realize this is kind of shadow boxing because we're not filling in the details of the for each and if statements. But what I'm doing, just to give you an overview, is to see if the customer has reached their end time or not. So I'm creating an else if statement. So in other words, if the customer is idle, then I'll do one set of things. However, if the customer is not idle, then I need to use else if, followed by, didn't mean to type that colon, followed by objc dot end time equals L ticker then. And what this statement does is if the customer is not idle, it looks at the customer object's end time property to see if it equals the current time in the ticker. In other words, the time of the simulation. If it does, then we will have it do some particular action. However, if it doesn't, then we'll have it do something else. I will specify what those something else's are in the next movie. So we have else if, and then I'll type end if. And this is the end if for object C dot is idle. Now we have one more internal if statement to deal with, and that is what do we do if a customer is idle and we're checking to see whether its next station is idle. So in other words, if a customer is waiting to move to station 2, we need to take a look at station 2 to see if it currently has a customer or if it has room for a new one. And that statement would go here below if object C is idle. So I'll tab in a couple of times again. So then we have if stations, and again, remember we're looking at station status, left parentheses, objc dot next station, right parentheses dot sta is idle equals 0, then, and then we need to add some more code below that. I won't do that in this case, but what I will do is to add a comment so I'll know what to do later. So just space in twice, single quote, add 1 to customer idle time if the next station is busy. So in other words, what we're doing within the simulation is tracking whether each customer is idle or not. If it is, then we add 1 to its idle time. And we'll calculate a customer's percentage of idle time within the system when we analyze the results. Now within this loop, or within this if-then statement, we also have an else. So I'll type else, colon, and then return, space in twice. And here is a long series of steps. Basically, this is the update to see what happens if the customer has been successfully moved to a new station. That means we need to move the customer to the station. We need to set the station's idle property to 0. We need to calculate the customer's processing time and set the customer's idle time to 0, and also set the start time property to the current ticker value. And again, we're tracking the amount of time that a customer spends in a particular station. So I'm just going to add comments here, and I'll add the code in the next movie. So move customer to next station, comma, set the station's idle property to 0. Enter. Another comment, calculate the customer's processing time, set customer idle to 0. I keep misspelling that. And then set start time property to current ticker value. Okay, that's a lot, but it will remind me what I need to do when I get to that later on as I'm working in my simulation. And I just realized that there is one thing that I forgot that I need to add, and that is above the end if for if the station is not equal to -1. And that is after a customer leaves the station, leaves the last station specifically, an artifact of the code, the way that I've structured the logic, is that I need to set the last station's idle to 1 because the code doesn't do it automatically otherwise, and I couldn't figure out how to do it otherwise. So I'm going to type above the end if for station not equal -1, I'll space in twice, and that's else, colon, stations, then L, number stations. The property is station is idle, spelled that way, equals 1. Then a single quote sets last station to idle when customer leaves. And again, what I did here was to set the last station to idle when the last customer leaves it. because the way that I had my looping structure set up, it didn't do it automatically within the code. Okay, this was a lot, and it's kind of abstract because you don't see what's going on within each of the loops. However, I had a couple of choices. Those were to create the outer loops with code in a single movie and then move on to create more code later, or I could do it this way, explain as I was going on, and then hope that you could follow more effectively in future movies. I chose this strategy because I think that hearing at least some of the explanations twice will reinforce what it is that you need to do when you add a ticker to a simulation. In Excel VBA, classes let you create instances of an object you use in your simulation. Those objects could be customers or stations within a process. One useful way to manage instances of a class is to create a collection. If you've programmed in VBA before, then you know the worksheets collection contains all individual worksheets within a workbook. In this movie, I'll show you how to create collections of objects in your own classes. My sample file is chapter 0104. That's an Excel macro-enabled workbook that you can find in the chapter 1 folder of the exercise files collection. We're working exclusively in VBA, so the worksheet itself is blank. I'll move to the Visual Basic Editor by pressing Alt F11. I have a code module called Module 1 that has a little bit of code already in it, and basically this just covers what we've done previously in this chapter. So I've already defined a variable called objc as type customer. What I need to do now is to define a variable as a collection type so that I can assign individual customers to that collection. So I'll go up to just below the previous dimension statement and I'll type dim, then a space, and I'll call the collection customers as, and then it will be type collection. So I'll type COL, and I see collection appear in the autocomplete list, so I'll press tab, and then press enter twice. So now I have variables that can represent an individual customer and also a collection of customers. But I haven't created the collection yet, or at least I haven't defined a variable as a collection. To do that, I need to use the set command, or keyword, to create customers as a collection. So I'll type set, then a space, and then customers equal, and then I'm creating a new object of type collection, so new, space, collection, and press tab to accept it from the formula autocomplete list. If you're running into errors where you're trying to assign a particular object variable to a collection, this is the most common step to leave out. So if you're having that type of issue, make sure you have a set statement where you actually defined a collection. They don't come in automatically. I'll press enter twice. Now I need to create a for next loop that allows me to assign values to multiple customers without doing the same commands over and over. So the first thing I'll do is I will define a counter variable. So I'll type dim L cust ID counter as long and return. So I have my counter variable for the loop, and now I can create the for next loop itself. So I'll type for space lowercase l custid counter equals, and I'll just do 2, so I'll make it 1 to 2. And I'll press enter, and just so I don't forget the next, I'll hit return a couple of times and type it. So now I'm 2 lines below the for statement, and I'll press tab to move in. Now I can use the set keyword to define a new customer each time we go through the loop. So I'll type set objc equals new, then a space, and I want to create a customer, and I name the class cCustomer. So I'll press tab and then enter. Now I need to add the object I just created to the customers collection. So I'll type customers dot add, then a space, and the name of the variable, which is objc. I don't need to set any other arguments or parameters for this particular command. I'll press enter. So what I've done so far is to define a new customer and to add it to the customers collection. Now I can use the counter ID and property names to assign values. So I'll type customers, customers, and then I need to identify which member of the customers collection I'm working with, and that is identified by the loop counter, lCustomer ID counter. So I'll type a left parentheses and then lCUST ID CNTR. Then I'll close the parentheses. So the first time through this loop, I'll be referring to the first or number one customer within the customers collection, and the second time, when the ID counter goes to 2, we'll be referring to the second member. Now I need to identify the property I want to use. So I'll type period and then CUST ID equals, and then lCUST ID CNTR. So what I'm doing is I am assigning, again, the counter variable to customer number 1 the first time through the loop, an ID equal to that number. So in other words, every time I create a new customer, it will get an ID, and it'll be equal, will reflect the order in which it was created. That's all I will do here. I'll just add one property. So I'll press delete a couple of times to even up the spacing. I'll click below next, and above end sub, give myself a little space again. And now what I want to do to verify that my code works is to print out the values of each customer ID in the collection. So I'll make a comment to that effect. So I'll print out values of each customer ID in the collection, and it's in green because it's a comment. So now I want to loop through my customers collection and print out the customer ID of each customer. Rather than use customers.count to discover the number of objects in the customers collection and then use a for next loop, I can instead use the for each command to move through each element of the collection, and I don't have to worry how many there are. So I'll type for each, 2 separate words and a space, and objc, and again that is a variable of type customer. So I'm looking for each customer within the collection of customers. Then return twice, a tab, debug.print, a space, and then obj capital C, period, customer ID. So what I'm doing is printing to the immediate window the customer ID for each of the customers in the customers collection. So I have those lines there. Press return twice and then type next to complete the command. And what we've done so far is to once again assign customer IDs to 2 new customers that we just created. And the for each loop will move through every member of the customers collection, which we know to be 2, and print their customer ID here in the immediate window. If you don't see the immediate window, you can open the View menu and click Immediate Window or press Ctrl-G. So here we go. I have the insertion point blinking within the code module. I'll press F5, and in the immediate window, I have customer ID 1, customer ID 2, which reflects what we did earlier when we created our code. Every VBA code module that we will create in this course requires variables to represent values used within the procedures. In this case, we will use quite a few variables to store values that include the number of stations in the simulation, the average processing time for each station, and the total time that an individual customer spends within the system. In this movie, I will show you how to declare those variables within Excel VBA and also provide commentary about how we will use each of them. My sample file is Chapter 0202. That's a workbook you can find in the Chapter 2 folder of your exercise files collection. We won't use the contents of the Sim Setup worksheet immediately. So I'll go over to VBA by pressing Alt F11. In the Visual Basic Editor, there are a number of windows that are available to us. The one that came up when I moved over is Module 1, which contains the main code for this particular workbook. If you don't see the Module 1 code window, then in the Visual Basic Editor, go to Window and click Module 1 Code. I'd also like to briefly review the customer and station classes that are included in this workbook. So I'll click See Customer. And here you can see the definitions for the customer class. There are 6 properties: customer ID, station, start time, end time, entered, and left. And underneath the variable declarations, there are 6 sets of get and let statements. Get statements allows users to read values from a property, and let allows them to write values to that property. You always have to have get so the property can be used, and let is optional but very useful. We will also be using a stations class, and if I go to the window menu and click See Station, you can see the station class that we'll be using in this chapter. It has station ID, the mean processing time, standard deviation, and also the next station. But for now, I'll go back to the Module 1 code window, and we can start declaring our variables. One important thing to mention, above sub main test, which is the main subroutine we'll be using, is the keyword option explicit. The option explicit statement requires that you declare a variable before using it within your VBA code. For relatively brief tasks, it's not necessary, but if you're working with a relatively large and reasonably complex bit of code like we're doing here, it will save you a lot of time. Misspelling variables so that they end up with having 0 values or some other mistake is a key cause of frustration, and it can take you many, many hours to find errors that are avoided by taking 10 seconds to type option explicit at the top of your code module. So with that out of the way, let's start declaring some variables. I'll put each of them on its own line. So I will start by clicking under Declare Collections and Objects within Collections. So I'll start with dim space and then objc. So I have lowercase obj followed by a capital C, and I will make that of type C customer. So that will represent members of the customer class that we defined and examined earlier. Now I'll do the same thing for the station class that we created. So dim obj capital S as C station. Now I want to define collections that will hold customers and stations. So I'll type dim customers as collection, return, and then finally dim stations as collection. So there I have those 4 variables, and I'll go down underneath declare loop counter, random, and processing time variables, and declare those variables as well. The first will be the station counter. In other words, the number of stations that are used in the simulation. So dim L for long, stcntr as long, and then press enter. So what I've done is define a variable. The first character is an L, indicating it's a long variable type, and then stcntr with capital S and capital C tells me that it's a station counter. And yes, I could use a single letter such as S, or if I were doing loops, it's traditional to use variable names such as I and J, But in this case, I want to know exactly what I'm referring to. That way I don't lose track of which variables refer to which elements of my programming tool. We can do the same thing for customer IDs. These are often used as loop counters, so I'll type dim space lowercase l, again it's a long, CUST-ID, CNTR as long, and press enter. Now I can type in the amount of time that will be spent at a particular station, the variable for that. So it's dim space lowercase l, STATIME. To me, that means station time, as long, and enter. And finally, I want to define a variable that can hold a decimal value that is generated by the random function. So just the same way that you can create a random value inside of a worksheet using the RAND function, in Excel VBA, you can use the RND keyword to generate the same type of random value. So I'll type dim, then a space, and it needs to be a single precision decimal value. So I'll type SNG, rand, space as single, and tab. And again, SNG indicates to me that it is a single. I don't use an S because S can also use string, which is another variable type. Now I'll cut the commentary a little bit as we declare a variable for the number of stations. That is dim L NMBR as long, and tab. Now assign a value for the number of stations. I'm drawing this value from the worksheet itself, and it's going to come from the cell in which I put the number of stations that'll be used in the simulation. So if I press Alt F11 to go back, you can see that the number of stations is presented in cell C2. It currently contains the number 3, representing the 3 stations here. So Alt F11 to go back, and the assignment statement is L NMBR STAS equals worksheets. Then I need to name the worksheet, so I'll put its name in parentheses and double quotes. That is sim setup dot range. And then I need to identify the cell that contains the value. Again, that's cell C2, enclosed in double quotes and parentheses. And the property of that particular cell or that particular range is value. And finally, I want to initialize the customer counter variable. In other words, we'll have multiple customers. And the way that we're working in this simulation, for this chapter, I need to initialize the customer counter variable to 1. So that is LCUST-ID. Need to make sure I have it capitalized properly. LCUST-ID, CNTR equals 1. Great. So that was a lot of typing, but what we've done is to define the variables that we will use later on in this chapter to create our first simulation. After you create a class in Excel VBA, you can define variables called properties that contain values describing the object. For example, you could create a class that represents workstations within a business. Each station would have values for properties including the station's identification number, average processing time, standard deviation of processing time, and the next station in the process. In this movie, I will show you how to define class properties in Excel VBA. My sample file is Chapter 0102, and you can find it in the Chapter 1 folder of the Exercise Files collection. The only worksheet in the workbook is blank. We're working in Excel VBA, so to move to the Visual Basic Editor, I will press Alt F11. This workbook already contains a class module called CCustomer, and I put a capital C in front of the class module name just to remind myself that it is, in fact, a class. Now, with that class module in place, I can begin defining variables and also properties for the class. I'll just do one, and in subsequent workbooks for other movies in this chapter and throughout the course, you'll find all of the class definition that you need. I just want to show you in a single step how to start doing it, and I don't want to make you do the busy work of adding in all the properties you'll need by yourself. As long as you know how to do it, I'm happy. First, you start by declaring your variables, and when you work in classes, it's usually better to use private rather than dim. So I'll type private, then a space, and the name of the first variable is preceded by a lowercase p, indicating it's a property value. And again, this is just a programming convention. It doesn't have any effect within the program itself. And then I'll type the name of the variable, and that will be CUST, and then a capital ID. Now I need to type as and assign a variable type, and I'll make it long, and press return again. So what I've done is create a variable called pcustid, which is of type long, so long integer, and it's private. It can only be seen within this module. Now I can use property declarations to allow the property to be set from outside and also to be read from outside. So I'll start by adding a comment, which I do with a single quote, and I'll type CUSTID, then a space, property. And again, that's just a note to myself. Now I can start the property declaration. The variable needs to be seen outside of this particular class module. So I'll type public, then a space, then property, PROPERTY, a space. Now I'll type get, which is GET, then a space, then CUSTID, the name of the property, followed by a set of empty parentheses, left and right, as long, and press enter. Now tab, and then CUSTID, and then PCUSTID. And you can see that the Visual Basic Editor added the end property statement after I finished creating the initial declaration of property get. So what have we just done? We have created a property called customer ID, CUSTID, and we have allowed outside users to read it using the get functionality that's built into properties or built into classes. Now, if we want our users to be able to set the property, in other words, assign a value to the customer ID property, then we need to use, instead of public property get, we need to use property let. So type public property space and then let, L-E-T, followed by CUSTID and a left parentheses. But now, instead of having an empty set of parentheses, we need to allow a variable to be passed to this particular procedure, the let procedure, within the property declaration. And that value will come from outside, so we'll just call it value, because it's being passed as a value, a space, and then we need to identify the variable type, so I've already typed as, and long, and return. And again, after I press return, we get the end property statement. I'll press tab, and now I need to create the statement that allows the value to be assigned. So pCustomerID, P capital CUSTID, which again is the variable I declared at the top of the class, then a space, then equal, and a space, and it will be equal to the value that is being passed to the customer class. So what have we done so far? We have first defined a variable called pCustID, which can be used to transfer variables of type long in and out of the property. The get method in the property declaration allows outside users to read the value, and the let method allows them to set the value. And the code within each of the declarations makes those procedures happen. In this course's simulations, we are modeling the flow of customers through a sandwich shop. This process has two main elements: customers and stations. In this movie, I will review the structure of the customers class, and then I'll use VBA to create an instance of a customer object and add the customer object to the customer's collection. My sample file is chapter 0203, and that's an Excel macro-enabled workbook you can find in the Chapter 2 folder of your exercise files collection. I won't be working directly with the values in the Sim Setup worksheet, so I'll switch over to the Visual Basic Editor by pressing Alt F11. I'm working in Code Module 1, and you can see that I have it currently open with the variables that we declared earlier in the chapter. If you don't see the Module 1 code window, then go to Window and click Module 1 in the list that appears. Again, our goal is to create a customer and also a customer's collection. So to do that, I'll go below the variables that we defined earlier, and I will add first a customer collection and then a new customer. So now, using the customer's variable that I defined or declared as a collection earlier, I can use the set keyword to actually create that collection. So I'll type set customers equal new collection and enter. I'll press enter twice to move down. Now that I have created my collection, I can add customers to it. For this movie, I will just add a single customer. So I'll just type a comment, add a single customer, press enter, and now once again I can create a customer object using set. So set objc, which I declared earlier as a type C customer, equals new C customer. So I have a new member of the customer class. I will now add it to the customers collection. So customers.add space, and then the object I want to add, so that's objc, enter. And now I'll create an abbreviated version of the customer by just setting values for two properties. So I'll have customers 1.custid equals 1, and then customers 1.starttime equals 0, and enter. So there I have all the declarations. I have created a new collection, and I have added a customer to it, assigning it a customer ID of 1 and a start time of 0. In this course's simulations, we are modeling the flow of customers through a sandwich shop. This process has two main elements, customers and stations. In this movie, I will review the stations class that is included with the workbook, and also show you how to create station objects using VBA code. Because each station has properties such as the station ID, average processing time, and standard deviation of processing time, I'll read the values from the Sim Setup worksheet into the objects. My sample file is the Chapter 0204 workbook, which you can find in the Chapter 2 folder of the Exercise Files archive. Before I switch over to the Visual Basic Editor, let's review what information we have here on the Sim Setup worksheet. First, we have the number of stations, and then we also have information for each of the stations that we're going to create. So we have stations 1, 2, and 3, and we have the mean or average processing time for each station, as well as the standard deviation. So with that information in place, let's switch over to the Visual Basic Editor by pressing Alt F11. The main code that we'll be working with is in Module 1, but what I'd like to do is take a quick look at the station class module so that we can see the properties that are available there, and also get a reminder of how they were created. So in the Visual Basic Editor, I'll go to the Window menu, and I'll click C Station. If you did not see C Station as one of the open windows, then you can go over to the Project Viewer, go under Class Modules, and double-click C Station there. In this case, stations have 4 properties. Those are the station ID, the mean processing time, the standard deviation processing time, and the next station. And all of those values are defined as longs. And below we have the property declarations, which we've seen several times before, so I won't go into any detail here. Now I'll go back to the main code module. So I'll do window module 1, and now I can create a new collection. I already have object S as type station, and again the C in front of station indicates that it's a class I created, and then stations is also available as a collection. We defined those variables earlier. So I'll scroll down, below set customers equal new collection, and I will do the same thing. I'll set stations equal new collection. So that's in place. And now I can scroll down to the comment that says create station objects and initialize values. And I will tell my code where to find the values for the number of stations. First thing I need to do is to activate the sim setup worksheet. And there's only one worksheet, so I really don't have to do it, but it's good practice to get into activating the worksheet explicitly. So I'll type worksheets, left parentheses, and then in double quotes, sim setup, double quotes, then a right parentheses, period, and activate. Now that I have activated the sim setup worksheet, I can identify the cell that I want to start reading values for my stations from later in this module. So I'll type range, left parentheses, and then in double quotes, C4, which is the cell, dot activate. Great. So cell C4 is currently the active cell on the sim setup worksheet. Now I'll go down below add a station. This is within the loop that creates the stations that will be used in the simulation and also reads in their property values. So for add a station, I'll type set objs, capital S, equals new, and it's a variable of type CStation, the station class we created earlier. And now I'll add objs to the stations collection. So stations.add, then a space objs, and we're done. Now we need to read in the values for the station ID, the mean or average processing time, and standard deviation. So I'll scroll down a bit and click under assign station ID and read mean and standard deviation from the worksheet. And just to remind us of what we're going for, I'll press Alt F11. And we can see that starting in cell C4, I have the headers for station mean and standard deviation. And then in cells B5 through D7, we'll be reading in the values. Now, one reason that we started in cell C4 is that we can use our loop counter to bring in the station ID. So we don't have to read in values here. And that's why we started in C4 instead of B4. So I'll press Alt F11 to go back. And I'm ready to type in the code that will bring in the values that we need. So the first, we have stations. And then which stations object do we want to use? Well, that will be the one that we're currently on. So we're using our station counter variable, which goes from 1 to the number of stations. So we have stations, and that would be L, stcntr, the counter variable, dot staid, which is the property for the station ID, equals, and that is also the station counter variable. So lst cntr. Then return, and now we can do a similar action for the mean and standard deviation, but we need to read those in from the worksheet. So I'll type in the first one, stations. We're still working with the same variable lstcntr. That's in parentheses, then a period, then sta mean equals, and now we need to use the active cell and offset it by rows and columns representing its position within the worksheet. We can use the LST counter, or the station counter variable, to indicate the number of rows that we need to go down. So to remember, pressing Alt F11 again, we're starting in cell C4 that's currently the active cell. If we offset by 1 row, we're in cell C5, which has a value for station 1. Offset by 2, we've got the mean for station 2. Offset by 3, we've got the mean for station 3. So this is a handy trick that you can use. Use active cell and offset in combination. So Alt F11 to go back. And it is the active cell dot offset. Then in left parentheses, we need to indicate how many rows and how many columns. The row is simply the station counter, so that's LST CNTR, then a comma, and the number of columns is 0, because we're going to be looking in column C, and enter. Now I will copy this code so I don't have to retype all of it. So I highlighted it, press Control C, and Control V to paste. I'll edit the property value from STA mean or station mean to station standard deviation. And I will change the column offset from 0 to 1. So I have read in those values, and I now have the mean, standard deviation, and station ID. However, if you're reading ahead, you see the next comment that says I need to read in the next station property. The idea behind next station is that I am creating basically a single linked list of stations. What I want is for a customer that is done with station 1 to look at the station next property and know that it needs to move to station 2, and the code can handle that for it. So how do we do that? Well, we can use an if-then statement. What I want to do is check to see whether the station that we're looking at is the last station in the list, in this case station 3. If it's not, then use its current station ID plus 1 as the next station, the station to move to. If it is the last station, in this case 3, then we want to set the next station value to -1. And we can use that -1 value as a check as we get into more and more complex coding. So I'll click below Set Next Station Property, and I'll start with my if statement. So if stations, and we're looking at LSTCNTR, the station counter again, dot station ID, STAID, is less than the total number of stations, which is held in the variable L, NMBR, STAS, then we can assign that station's next station property the current counter variable plus 1. So we have stations, LSTCNTR, dot next station equals LSTCNTR plus 1. So in other words, if the condition is true, that the station ID is less than the number of stations, which we read from the worksheet, then the next station is the counter plus 1. Then enter. And then else, followed by a colon and a space, stations LSTCNTR, again the counter variable, dot next STA equals -1. And then finally we close out the if-then statement with end if. So that was a lot. We got a lot accomplished in this movie. And what we've done is to define stations, made them part of a collection, and then read in variables from the worksheet so that we know how they operate within our simulation. When you use VBA to create instances of objects in Microsoft Excel, the program keeps those instances in memory until your code finishes running or you delete the objects deliberately. Excel handles object cleanup pretty well, but you can manage your computer's memory effectively by getting rid of objects you no longer need. In this movie, I will show you how to delete instances of objects and collections using code. My sample file is the Chapter 01-05 workbook, and you can find that in the Chapter 1 folder of the exercise files collection. The only worksheet in this workbook is blank. That's because we're doing all of our work in VBA. So to move to the Visual Basic Editor, I'll press Alt F11. The code in this module creates two customer variables, or two customer objects, and assigns them to a collection called customers. Then in the second part, the code uses the immediate window to print out the customer IDs of those two customers in the collection. And it does that by stepping through each member of the collection. If I want to delete the object variable for the collection, I can go to just above the end subline, and I do it there as opposed to earlier because I might want to insert some code that uses the variables that I might have destroyed a bit too early. And I'll type in the command set, S-E-T, then the object variable I want to affect, and that's customers, equal nothing. So again, what I've done is to get rid of the customers collection by setting the object variable that I was using to hold my customers to nothing. And again, doing so would free up the memory that was used for that collection. I've pressed the down arrow to move to the next line, and now I'll run the code by pressing F5. I see in the immediate window, which I could have displayed by pressing Ctrl-G, that the customer IDs 1 and 2 appeared as I expected. But now, if I go down to the immediate window and try to display the customer ID of the first customer, so I'll type debug.print, then a space, and customers 1.custID, and enter, I get an error because that object is no longer defined, and it comes out as a compile error. So I'll click OK to clear that, and it appears that setting customers to nothing has worked as intended. Again, Excel does a pretty good job of cleaning up the variables and objects that you've created after your subroutine finishes running, but it's a good habit to set your object variables to nothing just to make sure that your system has the memory that it requires for other tasks. After you run a simulation or have written any other code that uses objects, you should delete the objects from memory. Excel has good memory management routines that usually free up your system resources after your code stops, but it's still good practice to remove the objects when you're done with them. In this movie, I will show you how to get rid of objects you no longer need in your VBA code. My sample workbook is Chapter 02-06, which you can find in the Chapter 2 folder of the exercise files collection. We won't be working with any of the data in the worksheet in this movie, so I'll press Alt F11 to switch straight over to the VB editor. I open to Module 1, which is where we want to work, but if you see either of the class modules, then you can go to the Window menu and click Module 1. I'll scroll down to the bottom of Module 1, and just above End Sub, I will add a line, and here's where we will add the code to set our objects to nothing to free up memory. What we're going to do specifically is to set the collections of customers and stations to nothing so that all the customers and stations we created are gone, and we don't need to have them taking up memory any longer. So I'll type a comment for what we're doing, single quote, set collections to nothing to free up memory. And even in this simple case, a comment is very important. If you're writing code that will be shared with others, comments are the greatest gift you can give them. That also applies to you if you come back to a workbook about a year after you've worked with it before. It's amazing how quickly you can forget what you've done, and also how quickly it comes back if you use comments intelligently. Okay, so I've added my comment for what we want to do, and I'll just type in my two commands. So I have set customers equal nothing, return, and then set stations equal nothing and return. What these two statements do is to free up all of the memory that was assigned to the customers collection and the stations collection. In this simple example, it's not that many, but if you want to use the techniques that you're learning in this course to create more complicated simulations, then you might find this is useful. In this chapter, you will create a simulation that defines a series of 3 stations and moves 2 customers through those stations. The idea is that the first customer moves through the entire sequence before the second customer starts. That is an unrealistic scenario, but it provides a simplified framework that we can use as the base for more complicated models that we'll create later in the course. So what are the goals for Chapter 2? What are we going to do as we work through the chapter? Well, first, we will declare the variables that we need so that we have places to put the values that we use. Following that, we will define classes for customers and stations, then add stations with property values, and those will include values such as the station ID, the average or mean processing time, and also the standard deviation of that average. We will clean up any unneeded objects, and we'll finish off by running the simulation once and then altering our code to run the simulation several times. So that's what we'll do in Chapter 2. Let's go ahead and get to work. In the previous chapter, you created a simulation that generated random times for customers moving through a business process. In this chapter, we'll make that simulation more realistic by adding a timer or ticker that updates the status of every object within the system with every tick of the clock. The procedure is substantially more complex than just estimating times, but it's a helpful step toward modeling your system more accurately. Specifically, our goals for this chapter are to create an outline based on for next and if statements. Those loop through each of the ticks in the timer and also each of the customers and stations within the simulation. We'll add functionality to the if and for next statements. We'll write out the results of the simulation again using debug.print. And finally, we will run the simulation to see the results. So with all of that in mind, let's go ahead and add a timer to our simulation code. In Chapter 3, we added a timer to our simulation so we could track the movements of 2 customers through 3 stations. In this chapter, we will extend that model to include multiple customers added throughout the simulation. The specific steps we're going to take are to calculate arrivals using the Poisson distribution, then also to move the customer generation code from outside of the loop to inside of the timer. Again, instead of just using 2 customers, we're generating them at random times based on the Poisson data. Next, we will write the results of the simulation to a worksheet. We'll have too many to deal with reasonably using debug.print, so we will move out to the worksheet. And finally, we will run the simulation and also fix a mistake. It's possible some of you have already encountered it or realized what could happen, but in Chapter 4, we'll make it explicit and figure out how to fix it. So with all that in mind, let's go ahead and use multiple customers that arrive at random times. So far in this course, we have created a simulation that allows multiple customers to enter a business process that also has multiple stations. In this chapter, I will show you how to extend your simulation's capabilities. First, I will show you how to add code that will let each station handle multiple customers at a time. For example, if you have a sandwich shop, you might have 2 employees taking orders, 1 picking out bread, 2 putting toppings on the bread for separate customers, and so on. Next, I will show you how to add more stations, and finally, how to implement what are called rework loops. You can imagine a rework loop as a time when a customer needs to either spend extra time at a station or has to revisit a station because a choice they made either wasn't possible to implement or what they wanted was unclear. These are all useful capabilities, and I look forward to showing them to you later in this chapter. To be effective, a simulation must use random numbers to generate its results. After you run a simulation, you can delete its results from the results worksheet to make room for a new set of outputs. In this movie, I will show you how to use the name box to select the output cells on the results worksheet quickly so you can delete the values and run the simulation again. My sample file is chapter 0602, and it's a workbook that you can find in the chapter 6 folder of your exercise files collection. The results of the simulation that I ran earlier appear on the results worksheet, and you can see those here. And if we scroll down, we can see that the results go all the way down to row 145. And then there's a previous calculation here in row 146 that I just hadn't deleted. So what we have is data in the cells from A2, which was just below the header row, down to F145. If we want to delete the results in those cells, leaving G and H, which contain formulas, as they are, then click the name box, which is just above the top left corner of the worksheet, and then type in the range that you want to select. So in this case, I'll type A2, then a colon to indicate the range operator, and then F145, and press Enter. When I do, Excel selects all the cells that I indicated using my range. Now I can press Delete, which deletes all the values, and then to move to cell A1, I'll press Control Home. So now I am back up in cell A1, although the code that we created earlier actually selects that cell anyway. So what we've seen is that by using the name box, we can quickly select and delete values from the cells that would contain the results for our next simulation run. Thanks again for spending the time to work through modeling processes in Excel using VBA. I hope you've gotten a lot out of the course, and before we go, I wanted to provide a number of references so that you can look further into process modeling, both in Excel and using other tools. The first book that I'd like to recommend is Business Process Modeling, Simulation and Design, 2nd edition, by Laguna and Markland from CRC Press. In that book, the authors provide an intermediate to low advanced introduction to business process modeling. It's a great book, and I highly recommend that you read it. Next, I recommend the book Matching Supply with Demand by Cashon and Teravish. That book's published by McGraw-Hill Irwin, and it provides more of an operations research perspective on business process modeling and analysis. So instead of creating a simulation to model a process, they show you how to analyze various times and setups and so on to use Excel to find average results that would be typical for a process. One of my favorite examples in that book is looking at how changeover time between batches affects the optimal batch size. And finally, I'd like to recommend a course of my own here on lynda.com, and that is Solving Optimization and Scheduling Problems in Excel. Again, that's a course that you can find on the lynda.com online training library, and in that course, I talk about using Solver to solve optimization and scheduling problems. With all these resources and the others that you find during the course of your own research, I'm certain that you'll be able to take the knowledge that you learned in this course and apply it effectively for years to come. After you run a simulation or a set of simulations, you should take some time to examine the results to gain insights into the system you modeled. The code we've created in this course writes out information about each customer's progress through a series of stations in a process, but we could just as easily have written out information about stations and the time they spend idle and occupied. In this movie, I will show you how to gain insights into your operation by looking over a simulation's results as written by our code. My sample file is the Excel workbook chapter 0601, and you can find that in the chapter 6 folder of the exercise files collection. I've already run a simulation, and we can find the results on the results worksheet. So I'll click that tab now. And there we can see the results. The first thing I'll do is just a quick scan to make sure that no customers got caught in a particular station. If you remember from Chapter 4, I made a programming error in the early iterations of development. And what happened was that because it was possible for a processing time in a station to be negative, it could occur that a customer would never leave a station and subsequent customers would back up behind them. So I just want to do a quick scroll down using my mouse's scroll wheel to ensure that there is no such issue here. And I'll just keep scrolling down. Looks like everybody got through, except for the last 2 customers who didn't have time to make it through the system. But everyone else in column D is -1, which indicates their current station. So it appears everyone got through. The next thing that might be of interest is to find out if any customers exited the system out of order. For example, if a customer arrived earlier and left later, then there might be some issue with the station being backed up, or as we saw in Chapter 5, there might be a rework loop, something along those lines. And if we scroll down, we can see that customers 15 and 16 actually reverse their order. So it appears that customer 15 left after customer 16. So what that tells us is that the idle time for customer 16, which was 17 ticks of our clock, is what pushed them behind customer number 15. So we just take a look at that, and the idle time just stands out. However, they only left behind by 1, in other words, 1 tick of the clock, so that's not too bad. But for some reason, this customer took 64 ticks to process instead of 47, and if it happens consistently, that's something we should look at within our process. You can also take a look at the percentage of time idle. So I've created formulas here in column H, which is the percent idle, and I see that customer 1 wasn't idle for any of the time, whereas customer number 6 was idle for 18% of the time, and customer 16, who exited behind the customer who entered just after them, was actually idle for more than 1/3 of the time they spent in the system. So again, these individual items might just be anomalies, but it's always worth checking the data to see what you can find out. In the previous movie, we added code to our simulation to allow individual stations to handle multiple customers at a time. We indicated the number of customers that a particular station could handle by adding the capacity property and also indicating the capacities here. And we use VBA code to read those values into the properties. And the idea is to see how increasing capacity at the 2 stations with the largest average processing time would affect idle time within the simulation. I've set the mean to 15. So in other words, on average, we would expect a customer to arrive every 15 ticks of the clock. Now we can see how those values will change based on our simulation. With that background in place, I'll press Alt F11 to move to the Visual Basic Editor. I'm in Module 2, which has a subroutine called Additional Capacity, and what I want to do is run it to see what the idle time looks like within the system. So this is the code that we created last time, so I'll just go ahead and press F5. The simulation runs, and I'll press Alt F11 to go back to the workbook. I am now on the results worksheet, and if I scroll down, I can see that I have very low idle times. I have a 1 and 9, a 10. Here I have a 20 and a 24, and 14s, and so on, but a lot of zeros and other small values. So it's very encouraging. It tells me that both the idle times are going down, and of course the percentage of time that a customer spends within the process is going down as well. But now let's see how sensitive these results are to changing the mean time. So I'll delete my current results. So I'll go to the name box and type A2, then a colon, and then F is idle time, and I'll just delete down to 300, even though I know I didn't have 300 customers. And when I pressed enter, those cells were selected. Delete and Control Home to release the overall selection and go back to cell A1. So I'll go back to the Sim Setup worksheet, and I will click in cell J2 and edit that value to 10. So I now have a mean arrival time of 10. And if I scroll down my list of lookup values, I can see that I get a 1 at 35. So the largest arrival time that I could possibly get between customers is 35 ticks of the clock. But that is extremely unlikely to happen, as you can see from the probabilities here. So I'll go ahead and scroll back up. There's our mean. And now I can press Alt F11 to go to the Visual Basic Editor. Cursor still in the subroutine, so I'll press F5. And because we're adding more customers, the simulation takes a little bit longer to run. Not too bad, though. And now I'll press Alt F11. And here we are on the results sheet. And you can see already that the idle times are significantly higher. So we have our customers entering the system at smaller intervals than we did before. And as I scroll down, I can see that the idle times, instead of being a bunch of zeros, we now have quite a few in the 20s and 30s. So scrolling back up. So you can see that, as you expected, changing the arrival mean time will certainly increase the strain on the system, leading to people standing around and more idle time overall. In the previous movie, we added information about 2 additional stations, stations 4 and 5, and then, very importantly, also updated the number in cell C2 to reflect the number of stations. It was previously 3, and now it is 5. What's interesting to note is that the way that the code is designed in the VBA test module, we didn't have to change anything. All we needed to do was to update our information here, and the VBA test routine will read in the data automatically. Now we can press Alt F11 and switch over to the Visual Basic Editor and run the simulation. So I'll go ahead and do that, pressing Alt F11, and here we are. So I have clicked inside of the Add More Stations subroutine. This is the code that we created in the last movie, so I'll just go ahead and run it by pressing F5. Simulation runs for a bit. Everything looks good, so I'll press Alt F11 and go back to the main workbook. Okay, so here we have our results, and let's see, we added more stations. So I'm not surprised that the time in the system is more than it was before. So for example, we might have seen times between, say, 40 and 50 very commonly. Now we're seeing times going up to 93, as low as 67, and so on. Now I'll scroll down, and I'm going to get to the bottom of the list. I'm also checking for errors as I go, making sure that all the customers in the front were able to complete before the others behind it. And at the bottom, I see 7 customers that were not able to work through the entire system. So I can see 1 in Station 5, 1 in Station 4, 3 in Station 3, although 1 of those is idle, meaning that it completed Station 2 and hasn't started Station 3 yet, and 1 that's working its way through Stations 1 and 2 each. So everything looks good. It appears that given these constraints, we were able to get 190 customers through the system, and although there are 7 more waiting, we should be able to handle them before closing time. In the previous movie, we added code to implement rework loops in our simulation. A rework loop happens when a customer needs to visit a station again or needs to spend a longer time at the station. We're treating those 2 situations, at least for our purposes, as being identical. In this movie, we'll take the code that we wrote before and we'll run a simulation with it to see how the results affect the time that customers spend within the system and also what other customers' idle times look like. My sample file is chapter 0507, and you can find it in the chapter 5 folder of the exercise files collection. So just to reiterate briefly what we have a 5-station system we have our mean, standard deviation, and capacity. And on the results worksheet, we have a table that records the customer ID, the time the customer entered the system and left, the current station, which would be -1 if they're done with the entire process, whether they're idle, and the amount of idle time that they spent within the system. This worksheet also has formulas for calculating time in the system and percent idle, which I'll cover elsewhere. What's new is that on the right, I have a 3-column area where we can record the customer ID, station, and rework time for individual rework loops. With all that in place, we can press Alt F11 and go to the Visual Basic Editor. Here in the Visual Basic Editor, we have the code that we wrote to calculate our simulation based on rework loops. So I'll just click inside of the simulation subroutine called rework loops and press F5 to run it. So the simulation runs, and after just a few seconds, it creates our results. So I'll press Alt F11, and we see the results worksheet. And the first thing to notice is that a number of customers have actually spent more time in the simulation, which means that they had a rework loop somewhere. And if I look over here, I see that customer number 3 had rework time at station 5 of 5. And then customer 34 had 2 separate reworks, but they weren't too bad. One was 9 ticks of the clock and one was 6. And if we scroll down, we can see that customer number 121 had 2 rework loops, and they happened surrounding customer 120. So if we look over here, we might be able to see customers that changed positions. Let me see. So that was 120 and 121. Let's see if customer 121 left the system out of order. Nope. Looks like customer 121 left after customer 120. What can occasionally happen is that you will see a customer, such as maybe customer 142, that will leave before customer 141 because customer 141 was in a rework loop at a station with a capacity of more than one customer. So that's one nice thing that's built into the system. It doesn't look like it happened in this simulation, but it certainly could happen in others. Adding rework loops lets you account for the possibility that customers need to visit a station more than once. Again, no process is perfect, so it's good to include them in your own simulations. So far in this chapter, you have created a simulation that takes information about a series of stations within a business process, such as a sandwich shop that makes food to order, and applies that information to discover how long customers will spend within the system. In this movie, we will run the simulation to see its results. My sample file is the Chapter 0207 workbook, and you can find that in the Chapter 2 folder of your exercise files collection. So looking at the Sim Setup worksheet, I see the data that we're using as inputs to the simulation, the number of stations, and then the mean processing time and standard deviation for each of those stations. Now I'll switch over to the Visual Basic Editor by pressing Alt F11, and I go directly to Module 1, which contains the simulation code. If you don't open to Module 1, then just go to the Window menu and click Module 1 from the list of open files that appears. A quick recap of what we've done is we defined and declared our variables that will be used. Then we read the number of stations. We started the customer identification counter at 1. We added a single customer. And then we read in information about a series of stations that are equal to the number of stations indicated in the workbook. Then we stepped our customer through each of the stations by generating random values based on the mean and standard deviation processing time. We're going to write those values to the immediate window, and then we're going to free up our memory by setting the collections to nothing. And again, if you don't see the immediate window, you can display it by pressing Ctrl-G. So here's the moment of truth. I'll click in the body of the subroutine, and to run it, I will press F5. And as you see, the values for each of the stations, the time spent, have appeared in the immediate window. If I press F5 again, then I get a second set of results. So that's how you run the simulation. But if you want to run the simulation multiple times, you can do that by setting up a loop. You have done a lot of work in this chapter. Specifically, you've added code to your simulation module to manage a business process by creating a timer. With each tick of the timer, your VBA code updates the status of each customer and station, moving customers among stations at the appropriate times. In this movie, you will run the simulation and take a look at the results your code sends to the immediate window. My sample file is chapter 0305, and you can find it in the chapter 3 folder of your exercise files collection. We won't work directly with the sim setup worksheet in this movie, so I'll just press Alt F11 and go to the code. So I'm in the ticker routine module, and I'm going to click in the body of the test update on tick method subroutine. And now all I need to do to run this particular simulation is to press F5 to run the code. We've been waiting long enough, so I'll go ahead and press F5, and there is the run, and we can see the results in the immediate window. I will resize the immediate window so that we have a better look at the results. I'll scroll up to the top. So what I see is that the way that I'm printing out results show that I'm customer 1 and I'm at station 1 at time 1, and we see that customer 2 has been idle for 1. In other words, it entered the system at time 1 as well, and it's waiting for customer 1 to be done with station 1. And we see that customer 2 is idle all the way down to 20. Now we see that customer 2 is in station 1 at time 21, and customer 1 moves to station 2 at time 22, so it starts there. Now we see customer 1 moving to station 3 at 34. Customer 2 moves to station 2 at time 40, and customer 2 moves to station 3 at time 49. And from there, customer 2 can be processed in station 3, and the simulation will end. So what we've seen through all this work is that you can use a timer to move customers through a particular simulation. I have all of the code for this simulation in the chapter 03_complete workbook, which you can also find in the chapter 3 folder of the exercise files. So I encourage you to go through that code, and if there's anything you don't remember, then to go back to the movie where it was added and to look it over. We have done a lot of preparatory work in this chapter, extending the clock-based simulation we created in chapter 3 to add new customers as the simulation runs. Those customers' arrival times were calculated by using the Poisson distribution, and their time at each station was calculated using the normal distribution. In this movie, I will show you how to run your simulation, examine the results, and as it turns out, correct an aspect of station timing that I initially overlooked. My sample file is chapter 0405, and you can find it in the chapter 4 folder of the exercise files collection. I'm not going to spend time reviewing what we've done. Our code is ready to go, and we're ready to write our results to the results worksheet, which is here. So I'll press Alt F11 to move to the main code module, and with the insertion point blinking inside of our subroutine, I'll press F5 and run the simulation. All right, well, I didn't see anything here, but I'll press Alt F11 to move back, and here we are in the results worksheet. If we start at the top, we see that the first customer entered the system at 1 and left at 46. It completed all stations, so its current station is set to -1. It is idle. Its idle time was 0, not surprising for the first customer going to the station, and it spent 46 ticks in the station. That value is calculated using an if function. It looks at cell C2 to see if the customer did in fact leave the system. If it did, then it subtracts 2881, which is total ticks plus 1, minus the time it entered the system. And if it didn't, then it calculates the value based on C2 minus D2, the time it left the system, minus the time it entered the system, plus 1. So in other words, if the customer successfully made it through the system, we find out how long it was in there. And if it didn't, then we use a different method to get the same result. All right, so let's go ahead and scroll down through the Worksheets tab, or Worksheets page, and we'll see that everything worked as expected. When we get down to 144, we see that this customer here, which entered a 2836 out of 2880, didn't make it out, and the same for customer 145 and 146. And we don't have values of total idle time plus percent idle time calculated, so I'll just go ahead and select cells G146 and 147 and pull down, and we can see the customer results there. Because of randomization, your values might be different. But now let's see what happens and what can happen sometimes. So I'm going to rerun simulations until I get the results that I want. So I'm going to pause the video for a moment, and then I'll come back to the results worksheet to show you what I mean. All right, it took me a few tries, but I was able to generate a simulation that shows the programming mistake that I've made in the code as it currently stands. So everything that we see here looks good, at least to start. We see that we have customers entering and leaving the system, and that their current stations are moving along. So far, everyone has completed everything. But if we scroll down, we can see that customer 42 never advanced beyond station 2. In other words, it never left the system, and it never left station 2. But it's not idle. And you'll see that because that customer was blocking station 2, none of the other customers were able to move forward either. So the question is, what causes that result? And the answer is that if you look at the mean and standard deviation for our particular stations, you'll see that station number 2 has a mean of 10 and a standard deviation of 3. That means that there is a reasonable probability that calculating a number with that mean and standard deviation using the normal distribution will generate a 0 or negative value. So that means that testing the customer's end time will never result in a positive check because the end time is in the past. So what we need to do is to correct our code by making sure that each customer spends at least one tick of the clock in each station. So I'll press Alt F11 to go back, and I'll scroll down to where we calculate the amount of time that a customer spends in a station. That's right here. So I am at the objc.endtime equals L ticker plus the random number that we generate. I'll press Enter and line everything up, give myself a little white room, and I'll type in the code indicating that the customer needs to spend at least one tick of the clock in each station. So I'll add a comment, make sure the customer spends at least one tick in a station, Enter. And here's how we do that, just using a single line if-then statement. So if objc.endtime is less than or equal to L ticker. So in other words, if we got 0 or a negative value, we don't want that because it generates an error. Then objc.endtime equals L ticker plus 1. So in other words, we are setting the end time to at least the current clock value plus 1. Now I can press Alt-Tab to move to the main workbook. I'll switch to the results worksheet, and we have results all the way down to row 148. So I'll delete everything from column F over and press Control Home to move back to cell A1. So A1 is currently the active cell, although we have code to set it anyway. I'll press Alt F11 to go back and press F5 to run the simulation. Alt Tab, and when we scroll down, we can see that everything is fine. We don't have any customers that got stuck in any of the stations. And because of randomization, we do have some results rows that don't have any calculations, but that's perfectly fine. You should also rerun the simulation a few times to verify that you have no errors. This movie provided the culmination of a lot of work. We were able to add customers on the fly based on randomly generated Poisson distributed times, and also to fix a programming error. So if you see an error, such as the one I pointed out, always make sure that your assumptions about timing are correct. When you're working with clocks and checking to see whether a certain value is equal to another value, make sure that you're not generating negative values, as I was with the normal distribution, with a standard deviation of 3 based on a mean of 10. When you send your simulation's output to an Excel table, you gain the ability to analyze your results in many ways. Two of the techniques that you can use on your table data are sorting and filtering. Sorting lets you change the order of your data based on the values in one or more columns, while filtering lets you concentrate on just the results that matter to you. In this movie, I will show you how to sort and filter using an Excel table's filter arrows. My sample file is Chapter 0605. That's an Excel workbook you can find in the Chapter 6 folder of the exercise files collection. Again, I want to work with my results data, and that is on the results worksheet. So I'll go ahead and click its Sheet tab here, and I see my Excel table, which already has the Excel filter arrows here displayed. Now let's say that I want to sort the values in the system or in the table based on the time that customers left the system. To do that, I would go to the left system column, which is column C, click the table header rows filter arrow for that column, and then I can sort using smallest to largest or largest to smallest in this case. What I want to do is to sort from smallest to largest. That means that the first customer to leave the system will be at the top, and the last will be at the bottom. And I also might see my zeros at the top. So for example, if there were a couple of customers who didn't make it out of the system before the simulation ended, then I would see them at the top because their left system value will be 0. Now I'll go ahead and click Sort Smallest to Largest. There I see my 3 zeros, they're still in the system, and below that I see my other values. So I can start looking, and what I'm looking for is in the customer ID column to see if there are any numbers out of order. So I see here that 16 left before 15, and I'll just scroll down a bit to see if there are any other examples. Nothing is jumping out at me so far. So it is very possible that was the only instance of it happening within the simulation run. If you make a more complex simulation, perhaps with multiple customers, capacity at each station, and customers entering at the same time, and also rework loops where a customer needs to spend more time at a given station, then it's possible the results would be a little bit more interesting. I will undo the sort by pressing Ctrl-Z and scroll up. Now let's say that I want to show only those rows where customers were idle for more than 10% of the time they were in the system. To create that type of filter, I can go to column H, which is %idle, click the filter arrow, and I'll click or point to number filters. Then I'll click greater than, and in the value box to the right of is greater than, I'll type 10% and click OK. Doing so shows me the records for all of the customers who were idle for more than 10% of the time. And I can scroll down and take a look at those values. So it appears that most of the values were in the 10 to 20% range, but we had one that was 22.81 and one that was all the way up at 33 and a third percent. So, and also one here at the bottom that's about 30%. So it appears that out of the 145 or so customers who went through the system, not that many of them were idle, and for most of them, the idle time was typically below 10 ticks of the clock, although there are a few exceptions. So with that analysis, it appears that the percentage idle is at least reasonable, but of course it depends on your organization's goals. If I want to remove the filter, I can click the filter arrow that has the filter applied and click Clear Filter from Field, which in this case is percent idle. Excel tables are powerful and versatile tools. It's a shame more users aren't aware of them. One of the elements of Excel tables that I use a lot is the total row. You can add a total row to your table and use it to summarize values in a column, such as finding the sum of all processing times or the average time that customers spend waiting within the system. In this movie, I will show you how to add the total row and change how it summarizes your table data in a column. My sample file is the Chapter 0604 workbook, and you can find that in the Chapter 6 folder of the exercise files collection. The Excel table with our results is on the Results worksheet, so I'll click that Worksheets tab, and here it is. Now, if I want to add a total row, what I do is I click any cell in the table, and then on the Design Contextual tab of the ribbon, which I'll click now, I look in the Table Style Options group, and I check the Total Row checkbox. And down at the bottom, I get a total row, which summarizes the data within the table. And also note that even though we're at the bottom of the table, the column headers, which would normally say A, B, C, D, and so on, now have the names of the columns of the table at the top. And that's one feature of tables that I like as well, is that when you scroll down, the second the first row or the header row of the table is no longer visible, Excel changes the column headers so that that value is displayed. It's a nice touch that I find to be very helpful. One thing that isn't helpful is knowing that the total, or the sum, of all the percentage of times that customers were idle is 603.53%. In other words, idle time isn't something that you would necessarily add. So what I'd rather do is find the average of all those values. To do that, I will click the percent idle cell in the total row. And when I do, a down arrow appears to the right. And when I click that down arrow, I'm given a number of functions that I can select from. Or if I want to create my own formula, I can click More Functions. But in this case, I just want to find the average of the idle times, including the zeros and this one instance of 100%. So I'll go ahead and click Average. And I see that on average, customers spent 4.19% of the time they were in the system as idle. And that's not bad. It's less than 1 minute out of every 12 in their system, and that seems pretty reasonable. Now, even though Excel automatically puts a summary formula in the bottom right corner of your table when you add the total row, you can also add similar summaries to other cells as well. So for example, let's say that you want to sum up all of the idle time in the system. To do that, you would go below idle time and click in the total row cell for that column, click the down arrow, and then click Sum. And here you can see that the total number of clock ticks representing idle time within the system was 245. And you can do the same for other cells in the total row. So for example, if you wanted to find the number of customers who are currently in stations but were not processed before the simulation time ran out, you could count the number of instances of the number 0. Now in this case, it happens to be just 2 instances here at the bottom, but if you run a more complex simulation, then that information might be more meaningful. And finally, if you want to hide the total row, just go back up to the Design Contextual tab and clear the total row checkbox. If you bring the total row back, then you get your initial calculations as well. If you have a premium subscription to the lynda.com online training library, then you have access to the exercise files for this course. I downloaded the exercise files and have saved them to a folder on my desktop called Exercise Files. If you double-click to open that folder, you'll see that there are exercise files for 6 chapters, and if you want to access the files for a particular chapter, you can just double-click its folder, and there the files will be. If you don't have a premium subscription to the online training library, then you can create your own resources or just follow along. Hi, I'm Kurt Fry. Welcome to Process Modeling in Excel using VBA. In this course, I'll show you how to simulate processes in versions of Excel from 2010 to 2016. I'll start by showing you how to define classes, assign values to properties, and gather instances of a class into a collection. I'll review how to declare the variables you need, define the objects that make up a business process, and show you how to step through a collection using a for each loop to generate sample results, and showing you how to add a timer or ticker to your simulation. You will add multiple customers to your process using random arrival times, and then view the results of your simulation. I'll show you how to extend your simulation by letting a station handle additional customers, adding more stations, and adding rework loops. The final chapter shows you how to analyze your results in Excel. All of these methods provide the tools you need to develop and explore ideas related to processes at work and elsewhere. I'm sure you'll find that your time with process modeling in Excel using VBA will be time well spent. Dive right in. Before we get started with process modeling in Excel using VBA, I'd like to give you a brief overview of some things that you should know to get the most out of this course. The first is that we will be working pretty much exclusively with macros and Visual Basic for Applications code, so understanding how to set your macro security in Office will be useful. Also, you should have basic proficiency in Excel VBA. While the processes that you'll build as part of this course are a little bit complicated, at least on a conceptual level, I think you'll be able to get by fairly easily if you have basic proficiency in Excel VBA. So things such as variable declarations, working with object variables, and for next, for each, and if-then loops will all be handy. Unlike many of the other courses that I have created for lynda.com, you'll find that movies build progressively within a chapter. So what we'll do is we'll start by building the first part of a solution and then move on throughout the chapter until at the very end we have the code that we're looking for. That means that not every movie ends up with code you can run. So that you might make some changes and create a skeleton or perhaps an outline for a number of routines, and the code that you end up with at the end of a particular movie might not run properly. However, the workbooks will all contain the previous code from the chapter. So when we are building our solutions, especially in chapters 2 through 4, you will find that each subsequent notebook or workbook contains the code that you need. And finally, chapters 2 through 4 also include a workbook with the completed code for that chapter. So you don't have to worry about maybe making one mistake and having it cascade throughout all of the movies in the chapter. The code will be there for you to work with and to examine. In Chapter 5, I take a slightly different approach. I offer you 3 different extensions to the models that we built, especially in Chapter 4. And in that case, Chapter 5, Movie 2, will contain the build of a solution. In other words, we'll add the code that we need. And then Movie 0503 will have that code, and you will be able to run the simulation and see the results. So once again, if you are familiar with Excel VBA and you understand how the course is structured, I think you'll get a lot out of what you see here. Now that we have the code in place to run the simulation, we can write its output to the results worksheet. Debug.print works well for testing and for smaller simulations, but when you start generating hundreds of values as output, you really do need to use a worksheet to manage and summarize the data. So in this movie, I will show you how to write those values from object properties to a worksheet. My sample file is chapter 0404, and that is an Excel macro-enabled workbook you can find in the chapter 4 folder of the exercise files collection. We're pretty familiar with the Sim Setup worksheet, so I'll just give you a quick look at the results worksheet. This worksheet has columns for customer ID, the time the customer entered the system, left it, its current station, which as a reminder will be -1 if it's done, whether the customer is currently idle, its total idle time, and then we'll use the values to the left that we've collected from object properties to calculate total time in the system and the percentage of time that the customer was idle within the system. So with all that in place, I will press Alt F11 to move to the Visual Basic Editor. And we can add our code to write the values out to the results worksheet. I'm going to scroll all the way down in the Update on Tick code module until we're just above the end substatement. And here you can see that I have two comments. The first is to write results to the results worksheet, and the second is to step through each customer record and write the property values. So the first thing we need to do is to activate the results worksheet. So I'll click just below the comment to that effect and type worksheets, left parentheses, and then the name of the worksheet in double quotes, that's results, followed by right parentheses, comma, and then the activate method, then return. Now we're basing the rest of the code on the fact that the cell A1 at the top left corner will be the active cell. So I'll type active sheet, which is now the results worksheet from the previous statement, dot range, left parentheses, double quotes, A1, double quotes, close with a right parentheses, dot, and then activate. So we have activated the results worksheet and also cell A1 within that worksheet. And now I'll press the down arrow key and I can enter the code for writing each customer record and its property values. So we're going to step through each member of the customer's collection. That is done using a for each loop. So for each, and we're holding our customers in object C variables. So obj C space in customers. Then I'll hit enter a couple of times and I'll type next. Go back up and press tab. And now we can enter in the values that we're writing out. So the first will be active cell. And we'll use the offset method to tell Excel where to write based on the active cell. So the current cell, or the active cell, is A1, and we want to tell it how far away to move to write the current value. So type a left parentheses, and we want it to move a number of rows equal to the customer ID number. So for the customer ID number 1, it will move down 1 row to row 2. For customer ID number 2, it will move 2 rows down to row 3, and so on. So we have objc, which is our customer object, .cust ID. That's how far it's moving down. The column offset is going to be different for each value, but in this case, it will be 0 because we're starting in the first column and not moving over yet. Right parentheses, dot value, which is the contents of the cell that we're designating. Then an equal sign, and what we want the value to be equal to. So that will be objc dot customer ID, and enter. Now I will copy everything over to objc. So I highlighted that and press Control C. Now press Control V. Now we don't want to write in the same cell. Instead, we want to move one column to the right for the next value. So I'll change the 0 here to 1. Objc period, and we're writing out the entered property. Press tab to accept it and press enter. Then I'll paste in just like I did before. Move to the second column over, period, and we're writing in the left time. In other words, the time that the customer left the simulation. Enter. Then active cell.offset, we're going over 3. And in that cell, we are writing its current station. Enter. Paste again. And the column 4, or rather the cell 4 columns over, we are writing whether the customer is idle or not. And then finally, at least as far as writing for properties goes, we'll go over 5 columns and write out the value of idle time. And scrolling down, I see that I've already added my next. All right, so what we've done here is to add code to activate the results worksheet and also activate cell A1 within that worksheet. And we're stepping through the customer's collection and writing out these 6 values for each of those customers to the results worksheet. Each row will contain values for one customer, their ID, the time they entered and left, the station they're currently at, whether they are currently idle, and what their total idle time is. So with all of that in place, we can now move on to the next movie and run the simulation.